what's interesting with these sets is that, well, you don't create a set to put one item in it, so you know for sure that the same label will be shared by many items in the network. So that increases the value of that label in a way. Yeah, so I think I said everything I wanted to say here, and here I'll show you a different one. This is a screenshot from Library Thing. If you're into books and you haven't read this novel, I recommend to read it. This is on my profile on this social media. It's another example, but here it's very different. The content is not mine. I didn't write that book, even though it might be unfortunate for me. I don't write that well. So they refer to this type of social media as global content, but here, so the process is very different. The content is already there. IMDb is another example. But there are social features in the platform, because what the owners of the platform try to do, and especially with this library thing, it's really a community thing. So they hope that people can learn from other people about shared taste and then benefit by finding new books to read that they will enjoy. They also have some limited functionalities to share opinions and to maybe even have a discussion about the book. And for some novels that goes, there's a huge amount of content. There are also a lot of novels that there's not so much content. The tagging model is free-for-all tagging. Yeah, this does make sense, otherwise we wouldn't call it social media. If the content is from somebody else and the tags are also controlled by the owner, then there's nothing social left, right? But here it's also more common to have a bag model. What do I mean with that? Well, a bag is actually what we use in practice a relational database system for. In a bag, items can appear multiple times. So formally a relational system has only sets, right? So if you have bags, then you can count a number of times the item occurs, and that's what you see reflected in the size of the font in this case, of the word cloud, of the tags. Now that is interesting, because then you can see how you can guess how important a certain tag is, because many people apparently chose to use it to label this content in that way for themselves. But by sharing it with the others, you can see the relative importance for all these tags. And we will see more applications of the fact that items and tags assigned by people are connected to each other. So that's where I want to switch to. So this was very basic. You probably all knew everything of this. But now I want to switch a little bit to what we can do with all this social media if we are working on information retrieval. So some of the people in the room will be very enthusiastic. And other people might think like, oh, social media has another application. But this is my expertise, so it's the only thing I can talk about for a long time. And this actually does boil back to basically two observations. So the one is, and this is more as social scientists talk about social media, that the consumer becomes co-creator. So the roles in society shift. There's less of this separation between who creates the content that we use. And the nice thing, because this all happens online, you can see how that takes place. And that's what makes it interesting for computer scientists, and especially for people in information retrieval. We can see how data is used and produced by just looking at the data on the network. And these platforms, they make it possible to actually request all that information, just like you saw in the entree with all the edits of Wikipedia, for example. So because the edits are still all there, you can reproduce how it happened, and that can help your system understand what is happening. And that makes you find out automatically what is the controversial content. So it's these data consumption traces, that is what makes social media interesting. Now I'm completely agreeing with the privacy awareness track in this school, and I think it's a big problem that people underestimate that. But on the other hand, we also don't want to throw away the child with the bathwater. Is that English? It is a Dutch expression. So this type of research that increases the transparency and the awareness of the people, that is very important. Because for certain things, like the books I want to share with others that I like these books and you should read them too, then I don't have a privacy concern. At least not immediately. So there is a challenge, because maybe 10 years from now somebody says, well, you like that book, we don't want to hire you in our faculty. So the real value of social media for an information retrieval researcher is that the information representations that we deal with are much richer, and that increases their value. And I use in the rest of, well, the next part of the talk, I will use as an example the library thing network primarily, where we have all these different things. The core here is the people, the items, and the tags that they assign to it. Now you see that is important to remember, even though we hardly ever take that very serious when we process this data. But it's very important to see that this is a ternary relation. That's different from the people assign a rating to an item, which is a binary relation. Right? I give a certain number of stars to the book of Janet Winterson, but when I tag the book, the tag is from me for that book. Yeah? So they come here together. Now usually we will flatten this relation, but it's good to keep in mind that that is actually wrong. Right? There are certain cases where this propagates information to the wrong place in the data representation. To really treat this as a ternary relation in computer science analysis algorithms is quite complicated. And apart from that it complicates matters, I've also not encountered any research example where it increased the value, so where the algorithm did better. But maybe you can find that in your research. And then usually from the people we know a lot, and we might know what other people they connect to. And from each person we might know some information about demographics, like how old they are or their gender. And what's also interesting from the items, okay, items can reference other items, and they can have metadata assigned. Right? And here I use the word semantics, even though people would usually say that the tags describe the semantics of the content. But the word semantics is a bit dubious in science. It's used in many different ways, which is a meta-semantic statement. So these richer information representations, they are the user profiles, where we often know a lot about the people that are active on the network. We know about these connections between users, which also allows new applications. But it also allows you to understand the data that you find on the social network. And we can understand it better, but the computer can also understand it better because of that. And then in some networks you have all these comments and reactions, you have endorsing and sharing, all sorts of social behavior that suddenly happens in the public and can be reproduced, can be read by the computer. Okay. So the opportunity for information retrieval is to expand the content representation. And why do we want to do that? Well, the classic problem in information retrieval is that there is a difference between the way people who create descriptions of data use language to describe it, and later the person who are in need of that information will describe it as well. And that's known as the vocabulary gap. And in this social media we have a lot of evidence about how people talk, or write really, about items. So that means you have much more evidence for all these different type of descriptions that there are around. It's especially interesting for us as academics. I'll repeat that a few times through the talk. So we are often a little bit envious of these big internet companies that run a search engine and they have all these users that type queries and then they click on things. Well, the good thing to realize is that in social media you see a lot of this behavior that we complain we don't have the click data. Right? We do suddenly have all this data, or at least something comparable. So we can do similar things what other people would do with what they call usage or click data. We can do it with this social media data. Maybe it's as powerful. Let's go through an example. So yeah, and this is the side effect is that you get also more diverse views on the same content. And that you saw especially in this edit trace of wiki. So in library thing, we are limited to items, people, tags and ratings. And in this talk I will actually ignore the ratings. So I will just work with the items, people and tags. Now let's see what interesting things we can do with that. The fact that you have access to that relation. You can use it to find synonyms. Let me go over it. So this is an abstract representation of why you can find synonyms from social media. Imagine here there is the tag that I would query for. And what? Oh, you cannot see that. Oh, I have to use this. Oh no. Yeah. Okay. Thank you. No. It's moving. No. Which one was it? Yeah. Oh, that should do it. Yeah. Oh yeah. Yeah. Oh yeah. Okay. It always goes wrong when people present with laser pointers, so I apologize. It must be the background of the slide that the mouse pointer is not visible. Anyway, so we have the query, in this case written in the British way. So it will be equal to a tag that is assigned to a bunch of items. Right? But what is interesting is that all the people using these tags, let's now summarize them as British people. That's probably not accurate, but it's easy for the talk to refer to them as the British. And then some of these items will also have a tag assigned that is written by the American people. Yeah, so they misspell it actually. And then through this tag, there will be items here that you wouldn't find if you spell humor correctly. Right? And for the American, we can do the complete opposite. So, what can you do with this? Well, it's actually a very simple method, actually turns out to work quite well. So now, we look again, and here you have the users, and the items, and the tags. And we will just put in each cell in that three-dimensional space, we will just put the counts. So it will be the number of times the tag is used by this user or item. Or maybe in some networks, where it is set-based, it will just be 1 or 0. Yeah. Now we can project this three-dimensional thing, and that's what I said, we're actually losing information in that, but let's forget about that now. We just turn this UIT thing into a user tag matrix and an item tag matrix. And then if you have here, this would be the Q would be the humor, right? So we have the column, we have for all the items the fact whether the tag is assigned or not. So that column in that matrix is just a vector, right? So some sort of point in a high dimensional space. And then each of these tags corresponds to one of these vectors. And you can compare these two vectors with something simple, like a cosine measure or a Pearson correlation. Now, what we could say is that, okay, if they are synonyms, then I think they must be assigned to the same items, roughly. Right? So the similarity between the tag vectors must be high. But because they are synonyms, people will not use, they will use one of the two synonyms usually. Right? So in this case, in the user tag vectors, the similarity should be very low. Right? And if you use Pearson correlation, it goes below 0. It's actually between minus long and long. But you could also use cosine measure and then you do just a low number and a high number. Right? So if we are then only asking for the tags, okay, let me forget about that. If we only ask for the tags that are, I'm still going to try it another time. Oh yeah. Oh yeah. And do you want this one back? Or that's a bad deal, no? So, if the user similarity is low and the tag similarity is high, then this should be the things that are synonymous, right? And so it's a very simple trick. And it only works because we let people just use the network like that. So that's the value of this social media, having it online. Right? So we can actually look what people did and we know who did what. And because we know who did what, we can make inferences about what that means for, in this case, the tag information in the network. So that makes it very interesting. And then you, if you want to write about it, this was work quite old now, but it took a while before to publish it because people were like, yeah, how do we know if this information is correct? And you don't measure, you don't evaluate it in the right way. So I think for all the PhD students here, the step from an idea that works to actually proven scientifically is long. That's why you get the training in this network. So here are some outcomes. We had humor, funny, humorous, British humor, and then you see also some problem cases, Discworld series. Okay, and this is very interesting actually, that's why I highlight it. So apparently a lot of computer science people are on library thing, right? Otherwise this Discworld series, most normal people don't know what it is, I think. But it is some sort of sci-fi fantasy series that is very popular among what some people call nerds, but geeks is maybe more appropriate label for that if we talk about synonyms. Yeah, and for the word classic, you also find that these relations between the tags that you pick up, they make sense. Right? Now this is a bit of an odd case, like a BBC Big Read. Yeah, it is apparently for this series of the BBC, they read classics. Okay, that doesn't really make it a very good term as a synonym. But maybe if you're just an information retrieval researcher, you don't really care, because if you expound classic with BBC Big Read, you might find a few more classics, right? Even though it's not exactly synonymous. So, of course, we now did just one projection in this space of user tag relations and tag item relations. But really what would be interesting is to really consider it as a network. A network between the people and the items and the tags. And then if you want to work with that, you need an algorithm that takes the network also as an input. And one approach that has been used a lot on the web, for example, is using random walks. So we were starting to use random walk algorithms on this network. They are a bit different, and I'll explain that when we come by. But so what's also interesting to realize is that as opposed to the network that the web forms, what is nice in this social media setting is that all the nodes have a type, and it's very clear what node is what type. So we have items, tags, and people. And actually, when you think about it, when you enter the network, you might be looking at a person, for example. Then there are different things that you can do with the information in the network that are centered on the fact that you are looking at this particular person. So you can try to recommend people, or you can, for example, find people-related tags, and then you get an impression about that person, perhaps. Now, all these different tasks you can model with different types of random walks. So now we have something where, okay, we have a task that is labeled here, like we want more items like this item. And we have a network representation of the data that we collected from social media, and then we will use some specific setting of Wang algorithm. So the Wang algorithm is we use random walks. And then we can do all these different tasks in a uniform way, in some sense. So, and we wrote a long paper about it, in 42 pages in Toys, if you're really interested in more of the details. But let me give some examples. And let me keep track of the time as well. So, the so actually, Christian, how long do I have still?
Yeah, until 11:30.
Oh yeah, perfect. And you wanted me to leave some time for questions, right? So I have to speed up a little bit. So the start nodes we will actually let depend on the task. And then the rest stays the same. Now we take again this matrix, this cube, and we flatten the cube to different matrices for the different relations. And then we do it's a bit ugly, mathematicians are probably not very happy with this approach, but we just concatenate all these matrices like this here, and then we put some weights for some simple parameters, but there's still already 4 of these, right? That we use to say, okay, if we are in a tag, how often do we want to stay in a tag, or how often do we want to go to a person? And then we run these random walks, and we let them run for a while, and then we look at the state vector of the random walk. So we initiate, in this case, is personalized search. We have a user and a tag. That's tag recommendation personalized. We have a user that we highlight and a tag in V0, and then we let the walk run, and in Vn the probabilities have spread out over the whole vector, and we can look at the ones that have a high probability and say that these are recommended tags, or recommended items, or recommended users. Yeah, so all types of personalization can be implemented this way. Now, what's interesting is that it's not like random walks on the web, in 2 ways. One is we don't let it run till infinity, till it converges, which is the way the PageRank algorithm is supposed to work. Right? We just do a number of steps in the network. What's also interesting is because all these nodes have different types, you cannot always reach every type of node in every number of steps. Right? So in this case, if we start with the user, we can have an item here, and we can have an item here. But from this item to another item, we always need to go through a tag or a person. Right? And there are no item-item relations in this network. Okay. Now, this was I already said this basically, but here was then some data-driven measurements where we used the ratings, we app-used them. We didn't put them into the algorithm, but we just used the ratings as a way to evaluate. You can actually also use the ratings to update the numbers that are 0 or 1 to actually saying that one relation is stronger than another one. So if somebody puts 5-star on the item, they like the item better, so we want to walk more often over that link. What you see is the good thing is there is a shape with an optimum. Yeah, so. And then for the rest, it's just about data and algorithms and optimization and to find the best setting. And also, I think if you would do it now with the way library thing is now, then probably the curves that you get out become different because the network has changed. And this makes it very hard to reason about this type of data, because the people change, the data get richer, so maybe decisions you had with the data about your algorithms in 2010 are different in 2020. It's hard to say. You have to keep evaluating. But what I wanted to highlight, we talked about synonymy. So this is a soft clustering algorithm, and for search that means that if you query for information retrieval, you might find the items that have the synonym IR used. There is a similar, so here are the British and the US people, right? And here are a different advantage. If we look at a certain person, then if they use Java, if they are a programmer, they might mean things related to programming with Java. But other people, they might think with Java of an island or coffee or whatever. Right? So what you get is in the network, because of what people do, here all the tags related to Java are to items that are closer to the programming preference. So you can imagine that using this random walk over that network does help, right? It does help to sooner give these answers than these answers. You do need to be lucky that the person, when they queried and you use this data, that they were actually in the mode of wanting to read about programming and not wanting to book a holiday trip. Right? So this remains a problem. It's not solved with social media automatically. This may remain the hard problems of information retrieval. Now I'll very quickly do a different type of relevance of social media for search. It's a little bit separate from the previous one. But I'll go quickly so that we have more time for questions. But I thought it was nice to share. So at some point we were wondering again about these social media platforms, and we were thinking, are they a good indicator for artist popularity? Actually you might think like, wow, what a weird question. Well, me and the postdoc that were doing this are both very avid music fans. So we think this is interesting. But you can apply the same idea to many other types of social media. So one thing is that you can just ask the social media platforms. And for music, you have a few big ones. You probably have heard of Last.fm and maybe Spotify. Right? Now what's interesting, and that's why I wanted to bring it up, is if you look, then you see that these two are quite related in what type of items there are in the network. But this is very different. And this is similar to the fact of the Discworld in library thing. Right? So Spotify has managed to actually go to the houses of normal people, the way they provide the service and the benefits that they give. And then you see, if you look at what artists are popular, so what we did is we just collected this data over 3 months, and then every 3 hours we asked the platform, like, what are the most popular artists? And then what you get is that, oh yeah, I'm doing the same mistake. I'm not learning. So these two are quite similar in a way, Coldplay, Radiohead. But Spotify is very different. Right? So Spotify is different users, therefore you have different popularity. Now I'm not claiming that one popularity is better than the other one. Right? But if you know which network would be better fit for me, then you can choose where you take the recommendation from. So that could be one application. Right? Now what's also interesting, and Bitly, you have probably used that, or at least seen it. So you have these long URLs, right? There's Last.fm, users, RMP, the Fries artist, 2013 most listened. Okay, with Bitly you can shorten that URL to a few characters and then you can share it. And because Twitter has been wisdom to allow you only so few characters, a lot of people use these shorteners. Nowadays it's even a little bit hidden. But what's interesting with Bitly is that they provide an API that we, researchers, can also get a key for, and then you can look at what URLs are shortened. And what IP address, or at least group of IP addresses, what country has this URL been shortened in. So there's a lot of information that you can get. And in the original API, I'll come back to that later, you could also ask for content that has been shortened by keywords. So what we did is we made a list of artists that we thought could be popular, and then we asked Bitly, okay, who is shortening web pages that mention this artist? Now, no rocket science, it's just calling the API, but what we see is it is a very different list again. And now here we have some indication that people are listening to that music. Yeah? Here we only know that they talk about the music because they write the name on web pages that are then later shared in other services. Notice that by using this Bitly API, we didn't even have to call Twitter, right? But because people on Twitter will use the service from Bitly, even not knowing, because Twitter, if they use t.co, they also use Bitly, then with the API of Bitly, you can see what is popular on Twitter in a way. So again, we do this for 3 months every 3 hours, and we execute a script for that, and then we see big differences. So the big differences are the popularity is almost stable for an artist, right? And here it varies a lot. And then of course you could think, why is this varying so much? Well, in this case it was because they received 3 Grammy Awards at that point. So when we set up the experiment, we didn't know that that would happen, of course. But this is nice to see. So you see a response in the web, and that's the thing to remember. These static services, they don't react, yeah, but the web responds. So there is a very big difference. And with the web, we now talk about really the social web, because it is the people using these shorteners, so they are probably on Facebook or Twitter or something similar. Right? Otherwise they wouldn't need the URL shortener. So okay, is this good or bad? I don't know. So you can have popularity from one platform or from another platform. It's probably true that artists that are not ranking high on any of these, they're probably not very interesting for many people. But even that you could argue with, because my favorite bands are actually in that group that are not ranking on any of these. So what is the most useful way of measuring? That's not clear. And I think it's very task dependent. And that's also a problem for us researchers. Right? Now just to hammer on that one more time, I thought it was fun to show you, if you look for social media in IR on SlideShare. So SlideShare is another social media platform where people share their slides. And then social media in IR, well, IR is for people on SlideShare is investor relations, because there's all these people in the Silicon Valley sphere that want to get rich, and they use SlideShare to share their pitches. And then there's a lot of courses on how do you share your pitch the best way on SlideShare, and those are the presentations that come up. Right? So wrapping up. So one problem of getting the data remains there, and that is, in this case, we even released the code so everything was reproducible for this artist popularity study. But actually the Bitly in all their wisdom has decided to stop the provision of matching the content in the URLs. So the code stops working. And this is the thing to remember, right? The people running the platform are in control. And they actually also make it very complicated to get to the data, because the only way for them to earn money is to make it complicated to get the data, because then they can sell it. Right? So we have to deal with rate limitations, and then the fact that they suddenly decide, well, we don't provide this anymore. Bye bye. This is a paper that you should all read if you want to do some research on this. These researchers had access to the paid service from Twitter, and they used the streaming service, which is unpaid. And you don't have to read everything in detail, but what you see is that actually when this one goes up, this one went down. Right? So if you are counting things on the streaming API from Twitter for a number of keywords that they did in this study, then you get very different impression than if you have all the Twitter data. And how do we know? Well, we cannot know, right? We cannot know because we have either this one or this one. And most people use this one. So I don't know if it is just a fluke that they were unlucky or that it is a property, but it's very important to keep in mind that the way to get this data is a complication, and in some cases it might be safest to work together with the platform. Maybe do an internship there, and then you know for sure that you have the real data that you want to say something about. Okay. So take home messages when I go back to winter in Holland. What is interesting for social media is that it has such rich representations of content that we face a lot of trouble to create similar richness if we want to do it ourselves. Like if you take a newspaper, you need to try and find the sentiments and the entities, and you need to parse everything out. And here a lot of that parsing is done for you by the users of the network. They highlight what is important for them. It also has a lot of information about time and location. And location is important. We just saw that. All the psychology students sit together, right? Are social media academics alternative to click data? At least it gives us much more information about how people behave than the classic corpora that we had. There's still a disparity between the owners of the platforms and us, but we can get quite far in understanding the limitations. And then I think this is for, if you really want to do information retrieval, then this is the main challenge, and that is, can you define one theory of how you reason about the things that you can measure online? Or do you need to put in all this information about, well, this is a social media platform for geeks that only listen to indie music that nobody else cares about? And do you need to hardwire that? So if you would have one general way that would fit for all those use cases and populations, that would be very interesting. And I don't have the answer if that's really possible. And that's it. I don't have time for that.
Okay, thank you very much. Okay, we have time for questions. Okay. Questions, please.
Well, thank you for the interesting talk, really exciting stuff. If item popularity is so different for the different services, how could we actually help users to identify what the best service for them is?
Yeah.
So I'm a Spotify user, but if I had known that hip hop is the most popular term in it, I might have thought twice about it actually. But since these things are different, can you imagine any ways how we could increase? One of our goals is users controlling the social media and what they get. Could you imagine ways how users could be made more aware of that and how they might control, how to select the service they want?
Yeah, so maybe so that could be one of those tasks that are underexplored. But so you see a lot of aggregation activities always by parties like Google. But maybe the fact that they are in different social networks is what is so powerful. Perhaps you want cross-links between them. But so if you have more means to look at the social media platform in large, like those word clouds, you see immediately like, oh, this is maybe not for me. Another way you could think about is if you have your Facebook where you blog about things that you do, then maybe you can ask another platform to take a look at your Facebook profile or the part related to music to see if it's a good fit. So you could define similarity measures across these networks. I would think that is possible, and it could lead to better ways for users to understand, and also to understand where they want to put their information. Because where they put it is also the place where it will become most valuable.
More questions?
You talked about social media and the term social is central to this. And
Yes.
the big difference to Google and all other services is that social relationships are pretty much in the center. So for, I don't know, URL tagging or so, the social relationships are very superficial, I would say. But for Twitter or especially Facebook and similar media, they are very central. Could you elaborate on that a little bit? You know, could we leverage the social relationships even more in, you know, understanding the importance of artists and, you know, clustering and things? You know, could we draw more from the social relationships that are so central to social media?
Yes. I mean, it will be complicated, and I'm pretty sure that one of the speakers later today will also argue that a lot of things that will help you do those things are actually not so good for privacy perspective. So there are a lot of questions there. So to me, personally, I think there need to become more mechanisms that are in control about who gets access to the data. But of course there is a big problem with that, because once you give it to somebody, they might not throw it away even though they promise to throw it away. And I don't see a solution for that yet. So until there is a solution for that, we actually only see that the number of social features are diminishing, or at least what we can see outside. So what you see is that people on Facebook have learned indeed to control their settings more. And if you do a global count of number of open pages and messages on Facebook, that is declining. Whereas actually the total number is increasing. So people are keeping it to themselves more. And of course, I don't know if you've heard of this Project X in the Netherlands, but there was big trouble, and some girl had put her birthday party on Facebook, but not with the right social rights. And then some people decided to advertise that party, and it was in a little village in Groningen, and it got completely out of hand. And especially because the extra factor, the media, they accelerated that process. Yeah. So people are aware of the dangers, that's why they make it less accessible, that's why it's harder to make use of it. That's maybe, and only if we find better mechanisms to deal with the risk, then we can make more use of it again. That would be the answer I give now.
Okay, we have time for one more question.
Yeah, so maybe my question is a bit more specific than the others, but you talked about these random walks, and you talked about these parameters, alpha, beta, and so on that you use. And I wanted to know how much these parameters were evidence-based. So did you did some fine-tuning and change them a bit, and or how did you get these parameters?
What we did is you split the data that you have in a part for training and a part for test. And then on the training you do a guess and then you apply it to the test. And then you can do that multiple times, and it's called cross-validation. And then you can use all the data instead of just.
And were this some kind of global parameters, or was it specific for one node?
No, they were so these 4 parameters that you saw, they were global.
Okay.
Yeah.
And would you?
But then in the item tag matrices and there they are computed from the data.
Okay, okay. And would you think that there would be some improvement if you, for example, did this node specific or more in a more elaborate way?
So the problem is sparseness of data.
Okay.
So actually 4 parameters is a lot already.
Okay.
Apart from having these matrices. So you generally try to keep the number of parameters down because you need to tune them unless you have a lot of data. And, but there is a trend with this deep learning to make everything node specific, right? And so, but I'm not a specialist on that.
Thank you.
Okay, thank you very much, Arjen.
You're welcome.
Okay, now we have a 15 minutes coffee break, and then we will go on with the next talk.
Yeah. Yeah. Now again. That's why I think my first one is like an architecture.
Okay, hello again. So welcome to our second talk, our second invited speaker, and the first of the two Mercator Fellows that you're going to see. You have already seen some biographic information, and I've tried to be very short, so I'm very happy that we have Katy Börner here. I met her first as a keynote speaker at the LAC conference in Vancouver, was it 2013, I think?
Linked to each other. They are larger if they are linked to by many, many other articles, and they are size-coded by the number of links that they receive from other articles. And those which have a lot of in-links, they are labeled here. And so you can start exploring this, and you can zoom in and out in different areas. And what we did to make it more visually interesting is to grid up the entire two-dimensional space of all these articles. And then in each grid cell, you have an image that is not a logo, but comes from the most linked to article. So this way, you really now have a landscape of Wikipedia, which you can explore at your leisure. The other piece, which I didn't plan to show you, but which seems very appropriate, is a map of Last.fm music listening behavior. This was rendered using geographic information systems. The mountains here represent music titles which are more similar to each other. The valleys are those which are all over the place, but you have them labeled, and you can again zoom in and out. Let's see if I can do this here. And it's a big PDF file in this particular case, so you have to be a little bit patient with the online connection we have here. But you can also zoom out and you get to read about how this map was created. And ideally, I totally agree with the former speaker that ideally, everyone would be able to replicate these kind of studies, these kind of analysis, these kind of visualizations. And only then it becomes true science. And what we in our group are trying to do is to develop open data, open software, and open education materials that empower anyone to take these larger data sets and to render them into insightful visualizations, ideally actionable information. And yesterday we had really good discussions about the importance of emotions when you are changing your actions. So just understanding something, understanding climate change or waste, doesn't necessarily mean that you're now going to turn off that light, even though we don't need it right now. So how to convert, thank you, how to convert data into actionable insights, that's really the holy grail. And I hope many of you get inspired to try some of our tools, give us feedback, and also empower many of your students to not only being able to read and write text, but also being able to read and write data, to read data visualizations, and to make their very, very own data visualizations. So going to my official slides, And now I have like 25 minutes left for 48 slides, so good luck to me. It's a true pleasure to be here. I'm really glad to see all the different students and all the different professors. And this morning there was a big group of students there and all the professors on the other kind of side of the room. And I think it's important to do all the strategies and politics surrounding this Graduiertenkolleg. But I think over time, I think you should, and I think you will, mix extensively. This is a map of scientific collaborations using Elsevier's Scopus database. And some of you might have seen a similar map of Facebook relations. It's actually very, very similar, except that Facebook is not available to some countries, so there are some big black holes in there. But if you look at this, then you really see that science today is a global enterprise. The same applies to trade relationships and many other educational trajectories, etc. And what we are trying to do is to help all of us understand what we collectively know in terms of scholarly knowledge, and then use these larger maps of science, and you see many of them on display over there, and then there are a set of 100 maps now also on this display over there, to use these base maps, which are not base maps of our geography, but they are base maps of our collective scholarly knowledge, and then overlay other data, such as career trajectories, such as trends and patterns and opportunities. Where does the funding go? Where do good ideas, technologies, papers come out? Where do all the good graduate students come out? And ultimately you want to be a good place on these maps, a highly densely interconnected, highly active map place. And in the Center that I direct, we work with clients which ideally have their data digitized, and then they need to first of all make sense of that data, make sure that they have the right data, that there are no data errors in there, that they have all the file years they thought they have, that they over time start cleaning their data, having unique author names, unique journal names, unique address information, etc. And then after they did a lot of data cleaning, they can then work with us to use data mining and visualization tools to find their way through all that information, to find collaborators, friends, but also understand what competitors are doing, to identify trends and patterns and outliers. And so what we provide are tools that help them render these data sets into insights. I was curious to know how many of you work with data sets that are larger than a terabyte. So raw data sets that you have personal access to that are larger than a terabyte. So if you have it, please raise your arm. Okay, 2 professors, but no students. They don't share yet. So that's good to know, because as time progresses, I would argue that we may never have as much data as some of the astronomers, which have live data feeds from very, very big sky telescopes, or physicists working at CERN. But we are getting in the realm of large-scale data sets, especially if you look not only at publication, patent, grant, clinical trials, stock market data, but also at social media data. These are very, very big data sets. And you need very special skills to actually just manage that amount of data. If you have publication data, for instance, my BibTeX file or somebody else's EndNote or other bibliographic record data file, or all the publications of professors which are united in this Graduiertenkolleg, then you can start using tools to extract co-authorship networks. And you can analyze them over time and visualize the evolution of these co-authorship networks over time. So here each node is representing a researcher labeled by his or her last name. Whenever researchers collaborate, they are connected via these links. Links are color-coded by the year in which those relationships came into existence. So the orange ones are older ones, the green ones are younger ones. The node size increases as more and more papers are published, so you want a big node. And the darkness of the node represents how many citations you received. So what you want is a large and dark node. You do not want a large and light node, a light color node. And so when Ben Schneiderman, who is the largest node in this network, saw this, he framed it and he gave it to his dean. So that's one way of using these maps. But of course, you can also use it to see what connects and what doesn't connect. You will get to see that Xerox PARC has the opportunity to hire 3 very eminent researchers. Typically, each university has exactly one information visualization researcher. And that researcher works with an incoming, outgoing stream of students. And so sometimes these eminent researchers at the universities, they might collaborate with others, but they might just be busy collaborating with their own students. And also this data set is just one conference out of 3. There are no journals included, no books. So it's also a limited data set. But imagine how that network would look right now for the graduate colleague and how it would look like in 5 years. I think it would look different. You can also use a geospatial map, and you can overlay collaboration patterns here for the Chinese Academy of Science. And this is a country level map. So if the Chinese Academy of Science in Beijing collaborated with Germany, there's one line going from Beijing to Germany. And of course here now CAS is very dominant in the middle, and you see the entire network of connections going outwards. So a different way of representing co-authorship networks. We also do a lot of research for agencies, particularly funding agencies. They are very interested to understand the impact of different funding models. Here you have on the lower left the collaboration and co-authorship networks that evolved from R01, investigator-initiated research that the National Institutes of Health is funding. And on the lower right, you have the network of TTURC center funding. Both networks offer about the same time frame, about the same topic coverage, but they look rather different. So the centers that are funded, they have a much more densely connected co-authorship network than those smaller grants that are initiated by principal investigators. So if you want information to diffuse quickly, you might guess what network you actually want in your system. And then you could, of course, also do input-output studies. You could calculate the price of one paper, etc. So these are all other studies we perform. We also recently did a collaboration with Dirk Helbing's team at ETH in Zurich. And here we looked at the global scientific food web. So who cites whom, who eats whom's knowledge, so to say. And so here knowledge flows according to citation links. So if you cite me, then actually my knowledge flows to you. And if I cite you, then your knowledge flows to me. And we were interested to understand this global food web because, as you know, very, very soon, China does not only have more publications than the US or any other country out there, but also more citations. So this is a unique point in time, you could argue. And the big question is China then taking over the leading role, or is it very much dependent on the kind of knowledge it eats? And in this particular study, it actually turns out that it is extremely dependent on the kind of citations that go into Chinese publications. So I won't have time to go into details here, but if you're interested in understanding global scientific trends, you might like to consult that paper. Recently, we also started to communicate large-scale trends in science and also predictions of scientific emerging areas using moderators. So just like you have moderators for science forecasts, good-looking gentlemen and ladies in front of a large weather map, you can now have a large-scale animated map of science. And oftentimes here, geospatial maps are used also. And then you have a moderator, a lady in red, which explains to you everything that's happening in science. Where does the funding go? Where are the emerging areas? What trends exist? And then if there is an interesting trend, we might zoom in, and then there's an interview. Here you have an interview of our VP for research, and he just became a VP for research when we recorded season 1, episode 1. He was just a normal faculty member, just like you and me. But and he's interviewing Johan Borlen. Some of you might be familiar with Johan Borlen's work on predicting stock market behavior based on Twitter data that went around the TV and the social media. And Johan is now using Twitter data to help predict onsets of depression and bipolar episodes. And so basically, if you go to a doctor and you get diagnosed with depression or bipolar disorder, and then you tweet about it, hey, I just came from a doctor and I'm officially depressed. Then he starts logging your tweet data and sees in how far your activity online could potentially be used to inform your wife or friend or anyone you would list there that today evening you have to be extremely nice to your partner or friend, because he is very close to falling in one of those big black holes. And if the prediction is not correct, then you have been nice, even though you didn't have to. But if it is correct, you can really potentially prevent these major episodes of depression. There are all kinds of privacy issues involved in this kind of research. And so Johan is working closely with medical doctors. Obviously, you could have a form where if you are diagnosed, you can also check that box that you want this kind of tracking, and then you have to provide the contact person. And of course, this is HIPAA data, and it can be treated as such. And so this is a different topic. But then after the interview is done, we zoom out again, and we show more trends in science and basically foreshadow the next episode. And to be honest, given that these maps are so new, this moderation strategy, having somebody explain to you what is happening in science is not only useful for experts, but also for my mom and many people like her. And ultimately, these large-scale views of science technology environments and trends, I think, are really important for people's decision-making. Not only professional decision-making, but also personal decision-making. So I wanted to say a little bit about the Mapping Science exhibit. It's a 10-year effort. Again, 100 maps can be seen there. If you want to zoom into them, they're actually large-scale 300 dpi maps, which are not perfectly reproducing on HDTV TVs. Then you can go to scimaps.org and you can zoom into them. This is a clickstream map of science, how science is used, not only how scientists cite each other. So this is the usage of science. There's a map of science fiction. If you like science fiction literature, you might find some new books to read over Christmas or to give away for Christmas. Language communities of Twitter. And again, we here now have 240 map makers from many different countries, which are the authors of these maps. And I hope you enjoy them and you get inspired by them to map your very own data. We also have some maps from other areas, because just like you can use epidemic models to understand the diffusion of diseases, you can use also these models to understand the diffusion of expertise, global brain circulation, or of technology innovations, or of ideas. And so in some cases, the maps which you see are not necessarily maps of science, but maps of other domains which provide algorithms that can be almost immediately used to understand the inner workings of science. If you ever get interested to showcase all 100 maps at your institution, it arrives in these big crates. So you have people on speed dial you never knew existed. You will know about loading deck heights, etc. Maybe you didn't want to know this, but it's actually quite a feast to bring it to your institution. So starting January next year, we will have a really nice fabrication of this exhibit opening at the Center for Disease Control. They added their very own maps, and it's in the David Sensor Museum part of CDC, and it's a gorgeous building and environment. The exhibit also comes with interactive displays. Here you have a map of science and a map of the world and a touch panel display. And you can start entering your own name to see where you are on these two maps, what kind of expertise profiles you have. But you can also enter keywords such as cancer or any other keyword you might choose. And you will again get to see who is working on those and in which areas is this research conducted. You can also take your finger and drag it over a certain area on the map of the world, and you will get to see then overlaid on the map of science what kind of research is performed in this area of the world. And if you drag your fingers over the map of science. Let's say you select chemistry, then you will get to see overlaid over the map of the world who is working on this kind of research. So this is the touch panel display, and then we have some buttons for more interdisciplinary areas, such as obesity, for instance, where you would have to hold down many, many different fingers on the map of science in order to pinpoint it. But also we added some Nobel laureates, as again, oftentimes they make contributions to multiple areas of science. The exhibit travels great in trains, and some of you might actually have encountered that train. Did anyone see that train? It made it through 62 cities in 7 months. No? Oh, you went on there? Okay, so it was in there, and of course if you have such a train, you have to make sure that everything is equally interesting, right? Otherwise you create a bottleneck in that train. So you enter it in the back, and then you go through it, and you exit it in the front. And so if there's something that's more interesting than everything else, automatically there's a big combination of many people, and it's just not working anymore. So it's interesting to actually design this kind of trains. If you have a large display wall, many libraries now have one of those walls, and also research centers, you can use our maps as screensavers. And this way you can inspire many to engage in more professional data visualization. If you ever get to go to Tokyo, visit the Miraikan Science Museum. They have a very large-scale OLED globe, which you can use to overlay all kinds of data. If you make visualizations, especially if you make interactive visualizations, consider submitting to the exhibit. The next 10 years are devoted to tools that can be used to interactively access data, but also tools that empower anyone to select a data set, select an algorithm, and then render these data sets interactively. So we want people to not only read these data visualizations, but to make them. And that brings us over to these plug-and-play macroscopes you saw in the title of my talk. So I assume that many of you have used microscopes and telescopes. They help us to see things that are too small or too far away to be seen with our naked eyes. Macroscopes help us to see things which are too fast, too complex, too vast, just too complicated or too big data-like. And here they help us to pre-process the data, to analyze the data, to model the data, to visualize the data. And what we are working on are these so-called plug-and-play macroscopes, which use an industry standard developed by many, many different companies, so-called OSGI, Open Service Gateway Initiative. And typically you can find this industry standard in coffee machines and cars. It's just supporting modular software design. But we added what we call SciShare, which allows you to plug and play algorithms. This way we can take code written in Java and C and Fortran, etc., and we can wrap it up as a JAR file, compile it for different platforms, Macintosh, Windows, Linux, etc. And this way we can harvest, if you wish, algorithms developed in many different sciences. So here you have information science, biology, social network analysis, physics, and of course there are now also women coding up these algorithms. And oftentimes they use very different input-output formats, so the workflows which are used to generate the visualizations you just saw oftentimes have like 12, 15 algorithms involved. And oftentimes if you have n algorithms, you need n-1 data converters, because the output of every single algorithm is very different from the input to the next algorithm. And so these OSGI SciShare powered systems also help with development of converters and reuse of converters. And so here, just like in Wikipedia, you have users that are contributors and are at the same time also users. But what they need is this empty shell, if you wish, that allows them to upload algorithms and to wrap them up and then to use them easily. So computer scientists, and they are way cooler than what you see there in the middle, they are used to build that empty YouTube or empty Flickr environment. But here in our case, we don't use it to share images or videos, but we use it to share active code. And then we have an easy way to do custom tools by just basically copying in the plugins you really want in your life or in your research. And it's basically like assembling your own music library. So you just take your favorite, not songs, but algorithms, you put them in a directory, they show up in your menu system, and you're ready to use your tool. I won't have time to go into much detail, but what you can then do is to develop different tools for different communities. And then now you can really use the algorithms which are developed by different communities. And you can have a tool just for conversion. So you can read in many file formats, and you can save out many file formats. These tools are then taught in the Information Visualization MOOC, and the Information Visualization MOOC also features in visualization frameworks that I thought is relevant for some of the work I saw in the back here. If you look at the visualizations you saw, then you can oftentimes distinguish different types of visualization, such as statistical analysis, temporal analysis, geospatial analysis, topical, and network analysis. So these are our rows here. And then you have three different major columns. So there are micro-level analytics, so just me and my co-authors, or you and all your funding. The meso level might have an entire institution, an entire Graduiertenkolleg, and then the global level, all of science. You saw the initial map of all the collaboration across the globe. And if you know in which cell you're operating, then you can also gain access to the right data sets, to the right algorithms, to the right visualization metaphors. Because depending on how many nodes, for instance, you want to display on your screen, you will need to apply different types of aggregation and different types of visualization metaphors. So the visualization framework shows you an overview of the many different decisions you have to make if you want to render data into insights. So first of all, you should try to identify the insight needs that you or your clients have. So you could try to categorize and cluster something, or you might be interested to order, rank, or sort something. You might be interested to see distributions, or to make comparisons, or to see trends, etc. I think you get the idea. So that's the first column there. Next, what you can do with your data and in how far you can address those insight needs will depend on the types of data you can get your hands on. And sometimes it's a matter of you scraping it, sometimes it's a matter of payment, sometimes it's a matter of keeping your fingers crossed that the API doesn't expire, and so on. So there are many, many different considerations just in getting the right data, the highest quality, highest coverage data. And as you know, if you bring in crap, trashy data, all of your visualizations will not be very meaningful. So getting your hands on the best data is high priority for any kind of visualization work. Then there are different types of visualization. So we distinguish, in our framework, we distinguish 5 types. Then there are graphic symbol types, such as geometric symbols. You already saw these circles and edges. Linguistic symbols, you saw the size coding of labels in the Wikipedia map. And also pictorial symbols, where you could, for instance, size code the portraits of people associated with the different nodes based on some attribute value. Then there are graphic variable types, and I will show some examples in a moment. But basically, there are spatial and retinal variable types that you can use to encode additional data attributes. And ultimately, oftentimes you will want to interact with that data. So here again, there are different types of interactivities that you could provide. And there are different libraries which support different types of interactivity. So for the insight need types, this is the table which you will find in the Atlas of Knowledge. And actually there is a copy of it over there. And I will leave this here with the Graduiertenkolleg. I hope you have a coffee table somewhere, and so you can always just look it up if you like. What I did here is to go back to the pioneers in the area of data visualization. And those pioneers, they are in statistics, they are in geography, they are in cartography, they are in software development, etc. And you can try to understand what they thought the major basic task types or insight need types are. And here you see on the left-hand side what existed, and on the rightmost, in the rightmost column, you see what the atlas ultimately uses in terms of inside need types and basic task types. So I tried to do a superset, and I also tried to align the different types of terminology. And I think getting order into terminologies that comes from so many different areas of research is really very, very important to make all of this more scientific. And I think there are also good ambitions here in the Graduiertenkolleg to define what do you mean by trustworthiness, what do you mean by user profile, etc. And I think this is really needed if you want to do this interdisciplinary research. This is the initial table I showed. Now, each one of those two columns you can use. Sorry. You can use and you can cross-tabulate them. So here you have a cross-tabulation of the graphic variable types. So geometric symbols versus linguistic and pictorial symbols, and graphic symbol types, which are here the rows. So you have the spatial dimensions, which are x, y commonly, but you could use a third dimension, but you lose a lot of the other retinal encoding types then. Because if you have a 3D world, then objects which are farther away, they're also smaller. They're also darker and more blue, if you want to do it right. So you can't use two of the main visual encodings anymore. Size and color are not really going to work anymore. And that's a problem. So oftentimes our visualizations are just two-dimensional. But then you see different retinal encodings. So you have size, you have shape, you have rotation, curvature, angle, closure. And then for value, of course, you have value and hue and saturation. And you have some examples of those. Now, ultimately, that table is way larger. And so just like a table of periodic table of elements, you now have some which are already filled with examples, and you have some which are empty. These are combinations which have not been attempted yet. So feel free to make your mark and to start filling them. But maybe it makes no sense to fill them because from our visual perception and cognitive processing setup, maybe human beings are not really good in actually using visuals that are encoded this way. So that's a big job for psychologists and others, HCI researchers for instance, to find out which ones of those combinations are best under what circumstances. And there's some prior work to this, but I think there's a lot more work to be done. Now, if you have such frameworks, then you can start teaching students how to systematically render data into insights. And so we have been doing this since well, I have been teaching that course since 15 years at Indiana University, but since 4 years now, we are offering every spring an MOOC, which is a massively open online course, where students from 100+ countries come and learn about data and information visualization. So the next class will start January 12th. You're very welcome to come for free. You get, if you perform well, you will get a Mozilla badge, which you can put on your LinkedIn profile. The coursework you're going to do is identical to the coursework that 100 paying students are doing, which are Indiana University students. And IU students, they of course get credits for this. If you don't pay, you just get the badge. But I have now met many students that took the course first, and then a year later they knock on my door and they are now enrolled as a residential student at Indiana University. So this is a great way to get a lot of good students to come to your university. I won't have time to go into details, but there is a two-part structure. You get 7 weeks of kind of instructions and homework and exercises and new tools and cool data sets. But then in part 2, students work on external projects with real-world clients in teams. And these teams oftentimes have students from around the globe, different time zones, different disciplinary backgrounds, extremely challenging to work in these teams. But those teams which perform well, I would put my hand in the fire for those. Ultimately, they learn how to design their own workflows, from getting the right data reading it, analyzing it, visualizing it, selecting different base maps, overlaying different types of data, and then visually encoding this data using that huge table you just saw. And ultimately, we want students to understand that if you load an Excel file or a CSV file or an otherwise tab delimited file, then you will be able to take different columns in your file to render different types of data visualizations. And again, I might be out of time here, but from the author column, you could extract co-authorship networks. From the year and some kind of text column, you can identify bursts of activity. From address data, you can do overlays on top of geospatial maps, etc. And these are the different visualizations, including these bimodal networks on the right, lower right, that you can do using these tools. If you like books, we have some of those, and again, the Atlas of Knowledge is over there. Feel free to also pick up some of the handouts. There are also comic books, in case somebody likes comics, all over there on that table. And if you want to learn more, follow us on Facebook or go online to our sites. And I hope you enjoyed this, and I would be interested to see if you have questions.
Thank you, Katy, for this inspiring talk and also for your recommendations already to the very much geared to our graduate school. Questions? Yes. Please, Marie.
Hi, thanks for your book recommendations. I am very interested in comic books, so I'll check that out.
There are only two of them.
Oh, okay.
So much.
So I'm interested to know to what extent would that visualization framework that you showed, to what extent would that be applicable to smaller data sets, like less than 100 or something like that?
It's applicable to all of these three columns you saw. So from the micro level, just me and my 5 friends, to the very, very large scale level. But again, depending on the size of your data, you have to do different types of data preparation, different types of analysis. And to be honest, to go to the macro level, you oftentimes now need parallel computing algorithms and setups. But then the visual encoding also very much depends on the kind of output device you are using. So the deployment, which is the purple square up there, if it is a handheld and you can use pinch to zoom, etc., very different setup than if you, for instance, have printouts, like these maps over there, or you have a huge wall where in order to see something down there and compared to something up there, you actually have to walk physically over. So the output devices also have a huge impact on the types of data manipulation and analysis you have to do.
So, more questions?
I'd like to follow up on this issue of display and output devices. From what I saw from your presentation, it was pretty much flat displays, right?
Not 3D.
Yeah, for instance, not 3D, no haptics, or that could be new kinds of technologies that could help you, especially in walkthroughs and in understanding dynamics by dynamically investigating the visualizations you have. Could you see any benefits there? For instance, you referred to losing color and size as major factors of visualization. When you go half 3D with full 3D, that might be better. But what would you recommend in terms of using display technology?
So we have been, actually, I can tell you an interesting story. So I came to Indiana University because I wanted to use their virtual reality cave system. My PhD is in artificial intelligence, and I thought there's nothing cooler than having a 3D virtual environment where now sound and haptic and visuals are all 3D, just like in our real world, and having AI in the back end. I thought this is the coolest thing I have to do this. That's worth going all the way to America. It turned out that many of our users, even though it was visually stunning, they didn't want to stand in a cold room, which is typically dark. Back then the resolution wasn't good enough. I think this is all now changing. And basically stand there all day long with the wand, basically manipulating information objects. Then we went and we did a lot of active world research, Second Life for those which were born later. And still people didn't realize how quickly they could get a user account and go into these 3D worlds and collectively build worlds or explore worlds or learn in these worlds. So then we went back to 2D interactive interfaces. And that was better. We got more work done this way and reached a larger audience. But the moment when we went and printed visualizations, that's when everybody was trying to get business with us. And this was the weirdest thing to happen for me, because I thought this is so cool to have these 3D environments. But then only if you're printing things and stuff can't run away anymore, people can annotate and they can just unroll without any boot up time. This is when we reached the largest audience and people really were able to take information away from those visualizations. This is all 15 years back in time now, and these 15 years have seen well, in that time, Google Maps, for instance, came into existence. And I think it has been really good in teaching people how to navigate large-scale spatial environments. I believe also the news media have embraced data visualizations much more. And so they are now teaching data visualization literacy to a large audience. So I think many people are now able to even read interactive visualizations. Even though we just did a study across 6 US science museums interviewing 1,000 youth and their caregivers if they can read 20 data visualizations. And the results were extremely devastating for me, because basically what you see in USA Today, and for those which don't read that newspaper, it's basically 3 bar graph kind of figures, not 4, not 5, 3 bars, pie charts with 2 slices, not more. This is what people can read. If you show them a scatter plot, they might not be able to read it. And if it is important that they take information away from it, then you have to adapt the medium of communication to what they can read. And I'm an engineer, so I take that seriously. Of course, there is a huge need to invent the next iPad or to invent the next, I don't know, I guess interactive service robot. But there is a huge gap between what we think people can do in terms of data visualization literacy and what they can really do. So after seeing the results of this 1,000 subject study, I believe what the information visualization researchers have to do is to, first of all, embrace that result, maybe replicate it in different countries. I truly believe, or I hope at least, that in Europe it would be a slightly better result. In Asia it might also be a slightly different result. But we made all the study material available online, but it has to be translated, and we are not there yet. But if somebody of you wants to replicate that study, I think it would be a really important data point to have. Coming back to your question about new interfaces, so as you have seen, the second decade of the Maps of Science is all about interactive displays. So we believe after having 10 years of static maps, we have learned enough to understand what visual metaphors work, what kind of interactivity works or doesn't work, how much moderation is needed. And it is another step of translation. So just like coming from what is published by researchers to the atlas is a huge translation step, another, maybe even larger step is needed to truly make this valuable to anyone in the general public. And this second step is not extremely valued by academics. And oftentimes it's done by science museums or done by those which develop school books for formal science education. But it's needed in order to empower anyone to really truly embrace the value of data. And if you have new interfaces, we're always interested to get people excited about those by shipping it with the exhibit. So I would be interested to learn more about your work in that area. But right now, given the interest to help people understand the value of data visualizations, we try to present them with visualizations that they can hopefully read. By the way, I wanted to make a pitch. If any of you is interested to work with us, come to me and talk to me. Because I think the reason for me being here, and not with my family, is that we want these bridges, we want these connections. And there are many different possibilities here from what I understand so far. In terms of Twitter analysis, we just see there the Pulse of the Nation Twitter analysis. So there are at least 6 researchers at Indiana University which use Twitter data to get all kinds of new insights about human society, but also to provide very actionable insights. But then there's also a set of 12 researchers doing science of science studies at Indiana University. And so it's not just me you would be getting in contact with, but the potentially 150 network science researchers and many other researchers. We have a very strong cognitive science program at Indiana University also. We have a new data science program. So I think each Mercator Fellow don't see just them, but see their entire set of connections and their entire set of tools and data sets and all the exciting stuff.
Thank you again. Just a brief comment, or I think we do not have time for another question and answer. I mean, just. Give a comment. I also have a couple of questions, but we have lunch now and we have time for interaction. We have hopefully also time to have a look at your maps that are, part of them are displayed over there. Thanks a lot again, Katy, and yeah. So lunch is open in the other room.
1 second. Table first.
Okay, we will
Like, so I'm doing a review, like.
Yes, so we are ready for our next speaker, Ulrike Cress. She has a very unique position among today's speakers. She has accompanied our project from quite early on. Not in the first years, but in the recent years, she has been a contact for us, a support for us in a rehearsal that we had, so she knows about our research training group very well. Ulrike Cress comes from Tübingen, and she has two affiliations: the university, where she is a professor of empirical educational science, if we can say that, and at the Knowledge Media Research Institute, where she is the deputy director. She's very well known in fields such as computer-supported collaborative learning, so she brings now learning explicitly, learning technologies, and learning with technology explicitly to the scene. And she has models, interesting models about knowledge building and the evolution of knowledge building in networked environments. Yes, Ulrike, so
okay.
The scene is yours.
Thanks very much for inviting me. So I was a kind of test reviewer 2 years ago, and it was very impressed about what you planned for this research school. And you had a great mixture of psychology and informatics. And I was very happy when I heard that you succeeded and got the fund, and that now the PhD students already started, and it's a great thing to have this day, I think. So my topic is about knowledge creation and learning.
Type 1 or type 2 technology?
Yeah. One moment. It should work. Normally Mac realizes it, okay. Schatz, you can help me. Okay. Okay, it's about social media. What are the main features for social media? I would like to mention two of them. First, it links masses of people. So people cannot just interact directly, but it's a mass of people, they don't know each other. And second is that these people interact through generating content. So these people can utter something, they can write Twitter tweets, they can contribute to a wiki or whatever, and they can hyperlink or link these contributions to each other. So an artifact is created, a network is created. And this artifact normally is permanent, so even if the people change, the users change, the artifact remains, and the network of the artifact remains. And this then shapes what other users will have to contribute. So this change shapes what knowledge people can provide, and if this knowledge attracts attention or not in this community. So I would say just these two things change our perspective fundamentally. So in psychology, we are used to think about an actor, an individual. And here in the social media, I would say it doesn't matter what the individual does. It's not the situation that the individual contributes something to a group. But now it's important that his contributions get some attention from the group. So one's importance depends on the linkage to others. So I would say it's the network that defines the importance of its member. It's not if an idea is great when it's contributed or in a Twitter it's mentioned. It's just that people see it as great and retweet it and react on it. So this is the idea of social media. Sorry about this. Already moves. So I would like to show two hypotheses here in this presentation, and so some studies about it. My first would be that social media knowledge creation and learning has two agents in social media. One agent is the individual, who of course has the knowledge which has to be contributed in order to exchange knowledge, to create knowledge. But the other agent is the network itself. And when I'm talking about network, it's not just interpersonal bonds. It's not the situation that people contribute or talk to each other. It's the idea that this network is a kind of self-organized system. So it's really a system working. It has its own rules, its own roles and structure. So if, for example, in some network site like LinkedIn, in Facebook you would present your pictures of your party. You wouldn't do that in LinkedIn. You would present there your CV, but you wouldn't do it in the Facebook. So it's really the network that decides what is accepted or not. Or in Wikipedia, in our research, for example, wikis are in fact in Wikipedia. You know, in Wikipedia you have to be objective, you have to be neutral. We're also interested in Metapedia. Metapedia is a German wiki where the German Nazis contribute their Nazi ideology. And of course, something which is interesting for Wikipedia and which gets a high value there is not all interested in Metapedia. So Metapedia, you won't survive if you be neutral. You have to be more into the Nazi ideology in order to get accepted. So this is the idea that the network is really a system, is a social system with its own rules. So the network shapes the individual contributions. And the individuals who have to survive in the network have to fulfill the expectation of the group. My second hypothesis is that learning and knowledge creation, so dynamics in learning or in knowledge processes, happen through diversity and through conflicts. So if you have just like-minded people speaking about the same issues, there won't be any dynamics. So you have to introduce some kind of conflict in order that some kind of learning or some kind of knowledge creation appears. So this is well known in psychology from Piaget, which shows that people learn by perceiving something that they haven't expected. Then a kind of cognitive conflict occurs, and people solve this conflict through accommodation, and they learn something. In sociology, it's Niklas Luhmann who also talks about social systems, and he shows that it's a kind of irritation. The system is irritated, new roles, new behavior, new norms are established. And then a dynamic development starts, and the group creates knowledge in case of knowledge processes. This brought us to a systemic framework. So we see two agents in these knowledge processes with social media. We see a social system as this one agent, and the cognitive system as a second agent, and the conflicts or the incongruities between these two agents that trigger dynamics. So on the one side, we see the individual as a kind of cognitive system, which means this person processes information, and this system is self-referential. So you think based on your thoughts, based on the prior knowledge you have. Your perception is shaped through your prior knowledge. So it's operational closed. But on the other side, it's open for the environment. So you can perceive some things from outside your operations. You can be stimulated by your perceptions, and this then may cause irritation and may cause a cognitive conflict. So only if you expect something, if you perceive something you hadn't expected, some kind of irritation occurs, some kind of cognitive conflict, a la Piaget occurs, and this triggers dynamics, which is called learning in psychology. So it's a kind of accommodation a kind of conceptual change or conceptual knowledge, which we normally describe as learning. On the other side, we have a social system with the social media. For example, in a forum, in a wiki or a blog, people are communicating. So also this system processes information by not through thinking, but through communication. And also this system is operational closed and self-referential. So you understand communication based on previous communication. You can't understand it without any common ground. So it is a kind of self-referential autopoietic process which is going on. The processing of information is a bit different than the internal processes of a cognitive system. Here a group, for example, processes information by uptaking ideas, by ignoring something, by having ideas and bringing them further. This system also developed some kinds of rules, some kinds of norms, what is accepted as relevant, what is not accepted. But also this system, which is also operational closed, can be stimulated through its environment. So if something new happens, something which wasn't expected, it's a kind of irritation. And the system dynamically processes on this, and what happens we call knowledge construction. So some new knowledge, some new common ground is established, which then the system processes further. So in our coevolution model, we describe this as a coevolution of these two systems, cognitive system, social system. They both operate, they are both closed systems, but each system is environment for the other, which means these systems can stimulate and irritate each other. It's just kind of cognitive, kind of conflict, kind of incongruity between the systems. This stimulation can take place, and it leads to kind of dynamic development, which we can call learning on the cognitive side of the cognitive system, and knowledge creation on the side of the social system. We did some papers about this model, and we tried to use this model for some kind of different social media, for taggings, for wikis, for blogs. And I want to present here some kind of research that you have an idea what we do, which kind of research we are doing based on this model. So we normally use some kind of controversial domains, which means in order to have this irritation, to stimulate this dynamics, we need some topics where people have different opinions about. We let people then interact with social media, with tagging or wikis, and we, after the interaction, analyze if they learned anything. So it's a kind of incidental learning. We didn't ask them, you have to learn now. We just let them work on this social media, on this wiki, for example. Afterwards, we looked if something changed, and we analyzed the knowledge construction process. So we analyzed what other people, what kind of artifact do they create, what quality has this artifact. And then we try to analyze the coupling of these two systems. So the coevolution, if there's some kind of joint pattern going on in the dynamics. And normally we measure or we induce as independent variable a level of incongruity. So we want to see which kind of incongruity, which level of incongruity is the most productive. So I will present 4 studies. One is the role of incongruity in writing wikis, which is a very classical psychological lab experiment with highly controlled conditions. The second is that we try to, and then we provide some arguments pro and con this position. And normally we distributed these arguments across the different systems. So we give people some arguments they can read and they can recall, and we present them the arguments in the wiki. And then we ask people just to revise the wiki to make it as optimal as possible. And here, for example, we have a medium or high level of incongruity that the person has 1 con argument and the wiki has 3 con arguments. So there's a kind of different opinion going on in the cognitive and in the social system. Or we have this situation where they have completely different arguments. So the person just is con video games, and the group is, the wiki is pro video games. Or we have this kind of no incongruity. So the idea is that we have a possibility to manipulate in concretely at a very fine-grained level by providing different kinds of arguments, different redundant arguments, and so on. We let then the people work with the wiki, so they write the wiki text, they can enter their own arguments they received, and then we measure the outcome. We measure it on the group level as knowledge construction. And here we just look at the produced wiki text. So we can count, for example, the argument, which kind of argument does it have. We can see how well integrated are the arguments. Are they just listed, or are they interlinked in any way? Are they integrated? And we can see is the text balanced or not. So these are predictors or measures for the quality of the knowledge construction process. And on the individual part, we can measure the learning, so people can recall arguments they had before or they learned through the writing process. And we can see if their attitudes towards these video games changed, which also is, of course, a strong predictor for learning processes. And what we find continuously in many different studies with different topics and with different media also, that we find this kind of inverted U-formed relationship between incongruity and knowledge construction. So you have the best wiki text, the best integration of arguments, people have the most arguments, bring the most arguments into this wiki if you have a medium level of incongruity. And we see the same holds for learning. So people learn the best, they have the strongest change, the highest change in their opinions if they have a medium level of incongruity between arguments in the wikis and arguments people have. Now we try to reproduce this finding in the real Wikipedia. So here we search for another domain where we have a bigger database, and we decided for all alternative articles about alternative medicine, because we thought this should be a critical topic where there's much discussion going on. These were about 400 articles. These 400 articles consisted of 500,000 modifications. We used machine learning, so we had some human raters classifying if a modification was a neutral modification or was a modification bringing the article into the direction of alternative or conventional medicine. And with this test, with these human ratings, a classifier was trained, and we used this classifier for the whole data set. For example, here you have an edit in the Wikipedia history, and this edit contains of 2 modifications, one of the title, one of the test. And for each modification, our classifier said if it was neutral, alternative, or conventional. And from these data, from these 500,000 modifications, we tried to get some article profiles. So we tried to see how articles develop over time. We did this by aggregating all the edits of an article. So in the x-axis, you see the number of edits, and it depends on the article, of course, how many edits an article had. And on the y-axis, you see if it's more alternative or more conventional. So you see this article started as an alternative article, got a bit more less biased, and so on. Just to see, here you see some descriptive results about this. You see that first the power law, so many articles had only few edits, and the more edits, the less articles we have. But you see a very strong negative correlation. So the more edits an article has, normally, the less extreme this article becomes. So this was something that also was found by other groups in Wikipedia, that the more people work in an article, the longer an article is, the better the quality normally is, and the less biased the article is. With the authors, we did the same. So we tried to have the dynamic development of an author, and we aggregated all edits done by an author. Also here you have different number of edits, of course, depending on how active an author was. And this author, for example, started as alternative author and already remained as alternative author. Here you see some descriptives. So also here you see a power law. Most authors only had few contributions. Some had few hundreds. And the more contributions an author had normally, the less biased, the less extreme his contributions were. What was interesting, or what was the main purpose of this study now, was to see this delta. So if the incongruity between article and author predicts the number of edits an author does. So we measured this type of incongruity, the distance between the article and the author profile in the situation when an author worked on such an article. In the lab experiments, we had found this kind of, sorry. In the lab experiments, we have found this kind of distribution, so this inverted U-shaped distribution, and we found it several times, so we expected to find it here also. In fact, we found this. So what we found was that most edits were done with very, very low incongruity, and the more incongruent the articles were, the less edits there have been. It seems that we have a situation of high self-selection, that if people work, if they decide to do something in Wikipedia, they select the articles which are in line with their own opinions. They don't work on an article of the other side. They don't like to correct these different opposing articles. It seems that they are interested in their own positions and to write articles about their own positions. So we try to predict then if an edit was alternative or conventional. So in this figure here, we just see the frequency of editions. We don't see if this edit is in the one direction or in the other direction. If we try to predict this, we find predictors, which is very interesting, that the article profile predicts the edit independently, so its main effect independent of the profile of an author. So if an article is alternative, it leads an author to have an edit which is also alternative medicine, even if the author has the other opinion normally. So this shows how these articles shape what people do. It's really the network that shapes, that acts as an agent, not just the individual. And we see also a main effect of the author. So also an author brings in his or her opinion regardless of the opinion of the article, so both happens. And we see a kind of interaction. Here you see the key where that articles attract authors which have the same position in this scale from conventional medicine to alternative medicine. So our interpretation here is that controversy does not always lead to knowledge production. So it's not what we found in the lab study, where we found a medium level of incongruity was the best. What we see here in the real Wikipedia, at least in this corpus of alternative medicine, that similarity seems to be a main principle. It's a kind, we interpret it as resulting from self-selection, that authors contribute to articles they mainly agree on. And what is interesting, that articles become less extreme over time, authors become less extreme over time. And we interpret this as following from the rules of Wikipedia, that in Wikipedia you're forced to be objective, you're forced to be neutral. So by working on Wikipedia, people normally learn or internalize these norms and become more neutral over time. So also this could show that people internalize the roles and the rules of Wikipedia, and Wikipedia really works as an agent, as a self-referential system which is operationally closed. Now, next study about the intersection of topics. So here the idea was to have a bit more of fuzzy understanding of controversy, not by having on one topic and two different opinions about this topic, but about looking of different disciplines in Wikipedia. So if people have different disciplines, have different kind of thinking, and there can be conflict because between different disciplines because of this different kind of thinking. It's an old hypothesis in innovation research, for example, that most innovations happen between different domains or communities. So it's the same idea that you have interdisciplinary research, interdisciplinary ideas as the most innovative, where the most knowledge is created. So the idea is that we chose two disciplines, discipline A and B, which have an intersection, and to ask who writes this kind of knowledge occurring there within the discipline and between the disciplines. So we were interested in the creation of new knowledge within and between the disciplines, and we chose two different but overlapping topics, pedagogy and psychology in the German Wikipedia. So we took the domain classification of Wikipedia, so we selected all articles which are mentioned there as psychology articles and all articles which are mentioned as pedagogy articles. This gave us a network of 11,000 articles, and we used the undirected hyperlinks as edges of this network. So here you see a visualization of this network. So you see the articles, the pedagogy and the psychology articles, and the red dots are the articles which were classified as psychological articles as well as pedagogical articles. So the intersection. But what you see here already is that the intersection articles, the interdisciplinary articles, are not clustered as a third topic or third cluster. They are just included in the different two clusters of pedagogy and psychology. Now we looked at the relevance of an article, so we decided to measure this relevance with the eigenvector, which is a kind of measure for centrality. And we said an article is relevant for the pedagogy domain if it has a big, high eigenvector. And we did the same for psychology, so we said an article is relevant for psychology if many articles refer to it, if it's linked to many articles, if it has a high eigenvector. And we said for the combined network, consisting of both domains, we also want to have central articles. We say an article is relevant if it's central, but this time we looked about it between a centrality, because central articles here are the boundary spanning articles that are between these two domains. And then we categorized the authors. So we identified all edits from an author, which were more than just punctuation or so about a sentence. And we categorized an author as specialist if he just worked in psychological articles or in the pedagogical domain, or as generalist if he worked in both domains. And we measured how often, in how many other Wikipedia articles an author was active. So this is just the Wikipedia experience. And we asked if these features predict if an author's contributions are central. We did some regression model. So we did a model here for the psychologic corpus. We asked what predicts the centrality of an author in this corpus. And you see here the regression. So we were interested in the eigenvector of an author. So how central is an author in this network? And we wanted to predict it if he's a generalist or a specialist, and if he has much experience in Wikipedia or not, if he's active or not. And what we found with regard to the psychology network is that specialists are the most central people in psychology. So in psychology, somebody gets central, attracts attention, you could say, if he's really a generalist, a specialist. People working also in other domains don't have much chance here to get relevant. And if people have much experience, they do more, they also have a higher chance to get relevant. In pedagogy, we did the same, but here you see it's also a negative correlation of the specialists. So pedagogy, people becoming central in pedagogy are a bit more specialists, but not negative, not significant anymore. So it seems that pedagogy is a bit more open. So people coming from outside have more opportunities to get central, to get attention in this domain. And it seems to be a bit more open also for people having high experience in Wikipedia. And at last, we looked for the combined network, so of pedagogy and psychology. And here we looked about the between centrality, and here you see people in this interdisciplinary area, in this intersection, are mostly generalists. And this is a bit of a depressing result. You can say this intersection area seems not to be grounded in the original domains. It's not the people who are central in the domains who have anything to say, let's say, who become relevant in this interdisciplinary area. It seems that it's really a different group of people being active there. So our interpretation would be that central knowledge within the domain is mainly created by specialists, which I would say is a good finding because you have really the people having knowledge on that. It differs between disciplines, so we saw that in psychology the group was more closed than in pedagogy. The interdisciplinary knowledge is created by boundary spanners, and this is who are less central in the original domains, which I would say is not optimal. It would be better if these people are also very central in the original domains. And as a last study, we looked about the temporal development of this new knowledge. So we took the same data set, but this time we looked about the different temporal development. So from the period of 2006 to 2012, how this corpus developed. You see that we had more articles in psychology, pedagogy, more intersection articles, more links during that time. And so we asked what predicts where these links, where this new knowledge, these new sites are created, and who creates these sites. We used a multi-level logistic model. So logistic because we wanted to see if an edit happens or not, or if a new page is created or not. And multi-level model because we had now 7 time slots, points in time, the periods nested in an article. So each article had 7 time slides, you could say. Here we have I present the values for the new edits. So we ask who creates new edits, where do they occur, and here with regard to the combined network. So we see that the earlier an article is created, the less new edit it receives. Also, the older an article is within the article, the less new edit it receives. So it's a kind of saturation, which is also described for Wikipedia, that in the last years most central articles, most central knowledge is created, and now it's not so much going on in these areas. Then we can see here the centrality of an article in this combined network predicts how much edits this article attracts in the next period of time. So the between edits of t-1 predicts the number of edits at time point t. Here you see a positive prediction. We see also that the number of edits in the last period of time also predicts the number of edits in the next time. So if an article there was not much activity in an article, the activity stays the same in the next period. The excellent article doesn't have any difference to the non-excellent articles, but we see that the controversiality, the revises, have an influence on that. The same for newly created articles as neighbors, so the new knowledge not occurring on the article itself, but on the neighbored articles, so it's a bit more distal variable. You see here also the creation year and the article age have a negative prediction, so you also see here the saturation over time. You see that central articles attract more neighbors. You see that articles where much activity has been in the last period attract more neighbors in the next period. And you see also the controversiality has some influence. We also had an even more distal variable, the edit count at these neighboring articles. And you see here that we also have the same effect. So we had similar results. I only showed them now for the combined network, but we have similar results for the pedagogy and the psychological network. So the interpretation is that we clearly see a saturation in Wikipedia, which also is well known, I think. What we see is that central articles attract more articles in the next stage, which is well known in network analysis as preferential attachment. That the central nodes attract more nodes or more links in the future. So this shows, you could say, also the autopoietic self-referential nature of this network. So the network decides what gets central and where new knowledge is brought in future. You could also say the structure of the network shapes what happens in the future, shapes the dynamic happening in the future. And we see that the boundary spanning articles attract more edits, more neighbors, more edits and neighbors. So this is a sign that really the conflict, the discourse plays a positive role. If you have some boundary spanning, if you have some clashes going on between boundaries, this seems to be relevant that new knowledge is created there. So my take-home message would be that in knowledge processes with social media, you have two agents, individual agent and the network as agent, and that the knowledge creation happens writing or not. So in the real world, it seems that the optimal discrepancy is different, and we have more this kind of similarity. People select what they agree on. And we have this preferential attachment that the network itself decides where new knowledge is created. So I would go back to one of my first slides. I think it changes our perspective. I would say it's not the individual that matters in this environment. One's important construction. So it's the network that constructs knowledge. And if this knowledge is a good knowledge or a bad knowledge, like the Metapedia, the Nazi knowledge, it's out of our influence. So it's really the group itself, the community itself, that stands or guarantees for the rules and for the quality of the knowledge. It's an autopoietic nature, shows the autopoietic nature. It's a process of self-organization. And I would say the network analysis is an interesting and adequate method to deal with this. So we try to measure, for example, in centrality instead of objective quality. So we as researcher cannot just review if knowledge is good or bad. It's the idea that the network itself decides if this knowledge is central or not. We try to see the role of this preferential attachment as a characteristics of this knowledge construction. I would say this is another idea of user-centered. So in your logo of your user-centered social software, you have the user in the middle, reaching out or assessing other resources around him. I would say, for me, the new thing of social software is that it's user-centered in a way that the network decides about the centrality of the user. So it's another perspective. Just to mention my collaborators, this network stuff was mostly done by a postdoc of me, by Jassen. And if you're interested more in the systemic perspective, I would like to point you also to a book which appears next month or so, where also this idea and others are described. Thanks for your attention.
Yes, thank you very much, Ulrike. Happy to see that network analysis methods and concepts are used in this context. And also happy to see that Jassen is present in what we have also collaborated with him in what you presented here. Questions?
That was very interesting and enjoyable. I'm trying to go back to the beginning and work my way through in relation to the first set of studies. You, I believe, started with a premise that learning takes place when there is a gap or a conflict between the individual knowledge and the network knowledge. And then it seems as though your findings from the big data study suggested that, well, I'm not sure what you think this suggested. It could be that the individual saw art, in the case where individuals did not contribute many edits to an article that was very different from his or her foundational knowledge. Would you interpret this as saying that the individual learned something? The individual said, oh, I thought it was this, but now this article tells me it's much different. I guess now I know something I didn't know, and walked away? Or do you think the network teaches individuals because when an individual tries to correct something so vastly different, his suggestions get vetoed by the other members of the network? This would be a much different interpretation of where the learning is taking place, and I wonder what your interpretation would be.
The problem of the big data is that we do not have really knowledge data from the individuals. So in the lab we can just measure, we can have a recall test or whatever. In the big data we can't really see what happens, if they learn anything, and if people who contribute to opposing articles learn more than the others. We only have this kind of profile data. So I would say the only sign of learning we can have in the big data is that we can see that the articles get less extreme over time. And this is some kind, I would say it's an interpretation of learning, that people change during their work on the articles. And we can't just say it's in line with the Wikipedia rules. So for example, for us it would be interesting in the Metapedia, if we have the same idea, it should mean that people get more extreme. Because Metapedia is really a hardcore Nazi wiki, so it really accepts just hardcore ideas. And then the idea should be that if people learn from the group, they also become more extreme over time. But we haven't done this analysis yet. But I would expect it. And this means the network teaches, and it teaches just through cleaning and through accepting ideas or through ignoring ideas. And this kind of teaching takes place, I would argue. Yeah.
I think that would be a fascinating investigation in terms of how does the network teach the individual how to behave, to look at the kind of sanctions, approvals and sanctions and rejections. Because that would be the behavioral dynamic that would accompany this.
It needn't be strong sections. It's enough that, for example, contributions are deleted or are a bit changed. So we didn't study with a very outsider community of nutrition. So people who behave and you have to eat how things grow. You aren't allowed to wash, and if there's a worm in it, you have to also eat it and so on. And here we can show that people gradually take over the ideas of the network, that people start from relatively normal ideas, and the more they get involved in the community, the more they take over, they internalize these very strong ideas. Nobody would think in these strong ideas without the community, perhaps, but there we could show it a bit.
Mm-hmm. Thank you.
Hi.
That's really a problem.
I think you don't need it now.
Everything can go.
There's a last speaker, so that's fine. So your lab studies suggest that like medium amount of conflict is ideal for learning. But like in most cases in the real world, you can't really control how much conflict there is. So is the solution there then to reduce that conflict, or to continue advocating for your side of the argument? Or?
The idea which should be we shouldn't reduce the conflict. So these problems of filter bubbles or cyber polarization or whatever is discussed can be a problem, and we should make sure that our communities really have some kind of diversity, diverse opinions. And the more similar these opinions become, the more extreme, the less learning in a sense of being less biased can occur.
But doesn't diversity breed conflict in a way?
Yes, but conflict here would be positive if it's not too large. If it's a kind of medium level conflict, I would say it can lead to this accommodation process. So this is also an idea Piaget already had, that of course if you have a very big a very strong conflict, people don't accommodate. They just ignore or they do whatever. So you must have a kind of optimal level of conflict, then some kind of learning can take place. And my idea would be the learning needn't be necessarily something positive. So it can be the learning, also it depends on the norms of the community, which kind of learning occurs. But the idea would be for both kinds of communities, the good one, the bad one, you must have this kind of optimal level of incongruity.
I would like to contrast your take on the learning in such networks to something that we studied and that was not based on conflict. We looked at the commenting of Khan Academy science videos. And I really believe that people learn from these videos. Although this is not primarily through conflict, I would say at least. So we have studied certain patterns of question and answer that indicate certain types of problems of understanding that were dealt with. And we contrasted that to YouTube commenting. Because the same videos are also on YouTube. So you have a situation in which you have a moderated environment, Khan Academy, where it's a kind of quality control, and you have a more open, a free environment. But still, in both cases, it was not based on conflict. So the first challenge would be, would you accept there are also other types of learning in networks? And the other point is this community engineering. I mean, what happens if somebody's there who influences the network? I mean, who tries to balance, who tries to organize things, the moderator in a forum?
The first, of course, I would say there are other triggers of learning. So if you have the idea, for example, of zone of proximal development, normally it doesn't have to do anything with conflict. So learning can occur whenever kind of irritation, a kind of new perception comes in. This is, I would fully agree with you. About how to design communities I'm interested in this self-organizing community. So I would say, also in Wikipedia, if you have administrators or kind of moderators, it's some kind of coming from the bottom, so it's self-organized. If you try to do this top-down more, it's more on the instructional side, that you try to create artificial environment that bring people to interact and learn. And this may be positive, it may succeed, but we have often situations where wikis in school, for example, don't work because they don't have this spirit of bottom-up community, the spirit of self-organization. So I would say it's interesting to design communities, but I know only very few communities where this worked. So it's normally, I would say, it's a self-organizational process.
Some other? No, if there are no other questions and comments, thanks again, Ulrike. This ends the main section of our symposium with the individual presentations. Now we will have another coffee break, some reorganization, and then we will have a panel in which we will try to collect and compare experience from different ongoing, as we have to say, research training groups, RTGs. Okay.
Fürs Paper habe ich das definitiv korrigiert, weil ich das Modell neu gezeichnet habe. Da bei den alten ist mir ein Minus entgangen. Auch erst
We come to the last point in our program, our panel discussion. And the idea of this panel discussion was to compare the experience from different ongoing research training groups. Everybody has learned what research training group means, meanwhile, a very special construct of our German Science Foundation, DFG. So we would in first place address the issues and our models, how we deal with interdisciplinary collaboration in these groups. Usually there is also computer science involved, moderately in the one case and stronger in other cases. And I thought the first point to start with would just be to have a demographic round in which everybody says who she or he is and something basic about the research training group that you represent, and anything that you find important as a starter to learn about you and your research training group. Maybe we start with Fred Hamker from Chemnitz Technical University.
Yeah, okay. So, hello. You already said my name. So, I'm from the research training group Crossworlds. So, Crossworld is about connecting real worlds and virtual environment, also by an interactive way of with users and media technology. Media could also be avatars, but could also be like media platforms. It's not so much about social media, so that's what we have not covered, deliberately not covered. So the involved sciences are computer science on the one hand, and then media-social-psychology. And we also have quite interdisciplinary tandems, we call them. So usually we have a PhD student from computer science mixed with one from social or psychology. sciences, and yeah, so this is our focus. So myself, quickly, so I'm not a speaker of this research training group, I'm a PI. This speaker have asked for replacement because we soon have to extend our research training group in January, so we will have a visit then. So it runs already for 4 years now, so we have gained some experience at least with these interdisciplinary concepts. So maybe that's sufficient for now.
Hello, my name is Max Mühlhäuser. I'm from Technical University of Darmstadt, speaker of the research training group that has these devices as an issue. We basically consider the fact that by 2020, everywhere in the world, everyone will have a mobile device. We are close to that, and in a few years, it will be pretty much about everyone. And in many countries already today, like in Africa and China, the applications that people carry out on these devices are much more serious. It's not just communication, it's, for instance, financial transactions of all kinds. In Africa, actually, for instance, the crime rate has declined because people don't carry cash anymore. They do basically all their economic transactions with mobile phones. But that tells us that the apps get more and more serious, and there comes the problem. On one hand, the users, as we all know, get more and more transparent and visible for the entire network, so we need more and better privacy for protecting the user. On the other hand, the network itself that we link up to as mobile users becomes more and more intransparent. And therefore, we apply or want to apply methods of trust, of computational trust, to make the network more transparent, and privacy to make the user more intransparent, less open and accessible by means of all data. As to the interdisciplinary part, we have, of course, a strong core in computer science, but then we have sociology, we have rights, we have economics, psychology, so we have a good mix of interdisciplinary research, and I think we'll get to more details in the next round of questions.
My name is Marita Heisel. I'm one of the principal investigators of the user-centered social media RTG, so I think I will not say more about this RTG, only perhaps about myself. I'm a professor for computer science, computer science, and in particular software engineering, and together with Nicole Krämer we take special care of these privacy issues, and I think it's very much related to what you do, and it can be very interesting to have more intensive discussion about this.
So we have maybe we, yeah.
Okay.
Hello, my name is Nicholas. I'm one of the PhD students in the graduate school, and I'm working particularly with Professor Marita Heisel in privacy and security in social media. And I'm also part of one of the interdisciplinary working groups. It's information awareness and control.
Hello, my name is Guido Ertl. I'm a professor for organization and business psychology at the University of Münster, which is only 1 hour away from here. I'm very excited to see all these activities starting today here. I'm representing the RTG. I just learned this very handy abbreviation. We just say Graduiertenkolleg. Title is Trust in Communication in a Digitized World. So it's about digitalization or digitization. It's about trust, but it's also about communication, and that's why we have many communication scientists on board of this RTG. We also have psychologists. We also have information IT experts, Wirtschaftsinformatik, economic science, and we do have economic science, Wirtschaftswissenschaften, on board. So it's not that much techie RTG. It's also about technology, but it's also food from more social sciences, actually. So we do a lot of theory. I think Joe will like this. But we also try, of course, to apply these insights into the development of artifacts. So that might be a very nice link here. It's interdisciplinary, as I said, and we are focusing in this work in 4 different applied fields. So we apply these insights into the field of science, communication of science. We apply this into the field of media, trust in media. We apply this in work domain, in the work domain. Trusting relationships become more and more important when people work together. And the last area is sports. So some of you have seen the last news about Blatter and all these trust problems they are dealing there, and so trust is very important there. And we also see many digitized forms of dealing with these issues of trust, so that's interesting for us.
Yeah, thank you for the first one. Maybe I should add that my name is Ulrike Cress and I'm PI of this graduate school. I wanted to say RTG, we learned we have to say, and my field is knowledge and learning technologies. So some of us are by definition already kind of interdisciplinary. For instance, here we have a computational neuroscientist originating from electrical engineering. So we have sometimes interdisciplinary biographies, and sometimes we have a more disciplinary biography, but we work together between the disciplines. And that would bring me to the first question. How do we handle this, these facets that come with the different disciplines regarding methodology? I mean, computer science and psychology, they have easily subjects in common. That's what our department lives on, and it works very well. So about the subjects, that's not a problem. We study, computer-mediated or IT-mediated communication, collaboration, etc. But our methodology is quite different. And there, I think you have 2 options. I mean, you can say, okay, this is kind of we distribute the work. Psychologists are good at doing statistics and the empirical research, and computer science, they build maybe formal models, and so we just try to be complementary, or do we try to integrate? And that's of course very important for the scholars. If they have to live more this integrated model, or if they just do what they have learned and have to do in their discipline, and they just complement each other. Anybody wants to say something about that? Yeah, sure. Okay.
I can start from our experience. Well, we are in this RTG now for 3.5 years, so there's some experience we have on the run. And one of the main issues was first finding creating common ground in terms of principles and in terms of constructs, but also in terms of methods. And I think the interesting thing here is it's not about how will I do my studies, but also where will I publish my work. Because there are different outlets in terms of journals. I'm not sure whether you all plan to do publication-based thesis, but if you do, you want to make sure that you have the methods that are accepted in your community, of course, and that's a big issue. The way we solve this in Münster so far is that we do have tandems in supervising teams, actually two supervisors, one from each of the fields that are included there. But the main publications and the main studies are in one field. So the PhDs are usually in the field actually of the first supervisor. That doesn't mean that we exclude the interdisciplinary benefits actually, but it's helpful, particularly for the PhD students, to know from the beginning in which field I am addressing and which methods are most appropriate for this journal, for this community, to make a career there. So we still have this interdisciplinary principle, but in terms of career planning and doing research and also learning methods, we do have a clear focus.
Would be nice to have your opinion on that as a
The sound, excuse me, the sound is very distorted with this microphone. I think it might be better to switch it off.
The other one is better, or no?
Yeah,
no,
this
my
one you have
work
to hold
without.
it close to
Maybe
your
try
mouth
to
and the
do it
other
better.
far
Yeah.
away.
Okay, so I switch this off. So, okay. Yeah, okay.
Okay, no mic. First of all, on my defense, I'll say that we had started only for 1 month ago, 1.5 months ago. And I think that at least what we have achieved, it's to create different interdisciplinary areas and try to work together on interdisciplinary projects. In my case, it came because Joanna, one of my colleagues, is working also in privacy from the psychological perspective. But I think that made a common ground for us to complement our different angles.
Continue. So we solved it quite similar as in Münster, but probably not exactly the same. So we built tandems, but I've heard here that they should go as far as, for example, that a computer scientist is also doing some experimental work. So I think it's in principle valuable, but then there's always a time pressure. So they should finish within 3 years, or maybe not much longer later. And that is, I think, a potential conflict of doing this. So rather than learning all the other methods of the different disciplines, so we thought, okay, they should interact very closely. So they're sitting close together in the same rooms, and then they have lots of space for discussions, rooms for discussions in seminar styles, but also just on a private level. And they work on related topics, but their PhD is still in the domain where they're coming from. So they don't have to learn all the other methods of the disciplines, but they really get to know them quite well, at least. And I found this quite a good arrangement in terms of the compromise between time, acceptance in the community, and still some benefit from the interdisciplinary setting of such a research training.
Okay, I think we are discussing two issues here. One is the methods issue, how we get together in terms of methods, and how we organize, within the doctoral school. Let me return to the methods issue in order to create a conflict, and maybe we can then learn from each other. My conflict that I would like to create is, I don't think there is a fundamental difference in methods in these disciplines, especially in computer science. It depends very much on what kind of research you do, what kind of methods you apply. In cryptography, for instance, in security, you might actually end up with formal models where you evaluate by making proofs. And most of it is an engineering science, which is empirical in the sense that you build systems, you are constructive, but then you do experiments and you do studies and apply many of the statistical approaches and methods you apply also in observative empirical disciplines. And then there's HCI, an intrinsic informatics or computer science discipline, where you're very much on the empirical side. So we in computer science usually we have the full range, and it may be that you do a PhD in computer science and you have people from the other end of the spectrum and they kind of look down on you. This is not real computer science, the methods they apply, I don't know. So the methods issue, I think, is not so fundamental. You can always learn from one another, and of course in the social sciences the empirical part is much more elaborate, and we can always learn from one another, but it's not a fundamental difference. What I found in interdisciplinary research in e-learning, for instance, was models and terminology. The models, the ways of thinking, all the pedagogical theories you should understand when you do e-learning. And the same applies in the topics that we now represent. You have to understand the models, the concepts in the other discipline, and you have to understand the terminology, in particular if there's ambiguities. In the former experience, we could have 2 PhD candidates working together for 2 years until they realized that they used the same term in 2 different meanings. So it's therefore, and now I get to the organizational side, it's really important to have them work closely together in small groups, but also have 2 or more supervisors from different disciplines. But I would also fully agree that the PhD in itself should be topical, because in between 2 disciplines, it gets more difficult to be accepted, it gets more difficult to do the real thing for which you get accredited for a very good PhD, so you better stay in your domain, but you apply and you bridge over to the other discipline, and that gives you a lot of added value for your PhD, but you stay in your discipline and you defend there. And in the scientific community, it's always good advice for any PhD candidate, I think, to stay within one topic and one kind of community where you make yourself a name, where you understand how this community works, how it functions, in order to position yourself in one community, and then later in your career you can start to get multidisciplinary and multi-field.
I would like to agree on several points. For example, okay, the computer scientists should do their PhD in computer science because they want to go on with their career. I also agree very much that we should find a common language. But I would not agree so much on the statement that the methodology, the methods are not that different. It may be that different PIs from our RTG have different experience, but from software technology, you think about how to construct something. You think how to construct software. And I had the pleasure to read 3 psychology dissertations so far, because I was on the committee. We are in one organizational unit here, and I found that this was quite different. So I have learned that psychology is a natural science. So they want to understand something, they set up hypotheses, and then they do trials, and then they either accept or reject the hypothesis. This is not possible in software engineering. You want to construct something. And yes. So I think, at least for my subject, it is not the same. It's a completely different approach to what we are doing. And therefore, I would say, okay, we try some kind of integration by, for example, having some special lectures so that the psychology PhD candidates are familiarized with computer science method and vice versa, and that's good and necessary, but I think still it will not be a complete integration. We will still have some different goals in what we do.
Yeah, so I would really say the same. So I don't know, in computer science there's no education in statistics, at least not in our university.
Unfortunately.
And so they are blank in that respect. If they need it, they have to learn it then. And also we have in our research training group also qualitative approaches, so not just quantitative, also qualitative approaches, and they are completely unknown to computer scientists, so it's these kind of methods. On the other hand, so what are the methods of the computer scientists? Algorithms, so I don't know if these kind of concept algorithms and data structures, or what would you call the methods of computer scientists?
Modeling techniques.
Yeah.
They build up models, but they look different.
So
they
I also would say that I have some doubts that they are well known to psychologists or social scientists. So I really see that there's a big, a little overlap in the methods. But I also see that what I mentioned before, I don't think that they have to know exactly all these methods from the different disciplines. So, but they should at least get to know the relevant aspects to communicate with each other.
I would try to object, okay, to make this panel a little bit lively. software engineering, for instance. Of course, people construct something, and that takes long and long. And therefore, when they are finally done with their construction, they want to finish their thesis. But then the empirical part should start. And then the evaluations should start, and they should prove or try to build a hypothesis. By the way, they should start with the hypothesis first, and then build their system as a test environment, and then make tests and corroborate their hypothesis, showing that what they built is worth something and excels over the state of the art, which is very, very difficult. And I think that's the common goal of any PhD, to excel over the state of the art. And if you can just not by any means show that, then it's probably not even worth a PhD. And if you have algorithms, you can prove maybe some properties of that algorithm. Then you're in a formal discipline. If you do software engineering, you have to set up hypotheses and corroborate it by empirical methods and statistics that you should have learned before. And it's a pity if you don't learn that, but we should,
I think we do it here.
And then you talk about qualitative approaches in HCI. We take them to a certain extent. But what is it if you create a new programming language? How do you argue about it? It's almost like in some parts of the humanities where you don't so much observe and make hypotheses, you rather argue. It's more the hermeneutics approach, that is usually a different camp from the empirical part of that discipline. And we should have something like that also for architectures and for programming languages. So that's the point I'm making. Depending on what you do in computer science, you should learn from empirical sciences, you should learn from mathematics, you should learn from engineering, you should learn from hermeneutics.
And now I'm really tempted to say something myself, and I really want to add on. This is the point about the natural science paradigm that Marita also mentioned regarding psychology, and I have a long history of collaborating with psychologists. And I like to tease them a bit also, and so I always say, it's not about hard technical science here and soft human-oriented science there. Take pedagogy. Pedagogy is engineering. There your argument applies fully. The things, your constructs have to work. Like the bridge doesn't have to break down. For a psychologist, this is not the case. A negative result, that was an enlightenment. We always believed that this hypothesis was true, and now it is not. And this makes you rich in the community in a way, regarding your academic credit. This is not possible in engineering, and it's also not possible in pedagogy. Because it's a science that has a pragmatic purpose. And this is not the natural science paradigm. This is, of course, an applied science paradigm in a more general sense, and you could also, as a psychologist, probably adopt that to some extent. But in the core of psychology, you find the other argument also, that you're just observers of something that you're not responsible of. We are responsible of what we study. These are our children, our constructs. Psychologists, you study your children probably also. Sorry, that was something that I wanted to say.
As a psychologist on this panel, you're successful in teasing. What we are doing actually is, of course, it's natural science, but it's for purpose. And I myself, I have the application social psychology, but I'm now working as an organizational psychologist. So we consult companies. We give advice how to treat unemployment. We give advice in many areas of clinical psychology. So we do. We make a difference actually in what we are doing, and we have responsibilities because what we are saying based on our empirical research has consequences. And this is actually the impact of this controversy we have right now with the replication crisis we have in social actually, but basically it's cognitive and social psychology. So I wouldn't say that this you can play around, but we have responsibilities. I think we also have responsibilities. What I'd rather say is, in terms of efficiency,
Of course, it's wonderful if people are perfect in statistics and methods and also can build nice architectures and programs and advice, but you can't do this in only 3 years. And we already ran into problems with some theses that were highly ambitious because, and successful I'd say, because they had done wonderful research, had published this, and the review line with all the reviews and revisions and another revision requests take a long time. So, for example, we have one of our students just had published part of this thesis in Psychology, which is one of the major research journals in psychology. It's a big success for him, but it took more than 1 year only for this publication. It was a meta-analysis, by the way, not empirical research. So thinking about doing the research, then writing the paper, and getting stuff published in highly ambitious journals just takes time. So in order to really realize interdisciplinary research, which I'm a big fan of, would mean for me to think about the right incentives and the right structures. And that would be, for instance, projects that are where people collaborate from different disciplines, but where all of them can get the credit for this. Because that's a big problem right now when we have, for instance, a project with a computer science and psychologists and economists, and they all do this big project and then they write one paper. So who gets credit for this paper when there's only one first author? You can share the first authorship, but I'm not sure that we can share this among 3 people.
It even depends on the journal.
And it depends on the journal, and it depends, and maybe even more important, it depends on your promotion, on your PhD certification process. So if this can be accepted, and this differs between faculties. For instance, we have faculties that still do not accept that part of the dissertation is published before the dissertation is handed in. Some of them, they are changing it. But I'm just saying, if you really want to have interdisciplinary PhD projects, you might want to think about incentives and structures where you have a realistic goal that you can achieve within 3 years, and all of you get the credit. If you achieve this, this will be wonderful. But it's difficult, and I think it's not about expectations, what the students should do, like they should learn statistics and learn this and that. I think it's more about setting the right structures and, in a way, incentives.
Maybe at this point, are there questions, comments from the audience? Please, yeah.
As I listen to you talk, I'm not sure, in retrospect, I understand what your goals are for the PhD students who enter the new program. Is it that you wish to create future scholars who can form a diverse team, or do you wish to create future scholars that have their own diverse biographies? Or does it depend on the individual? All of those things would be fine. I guess I had thought, because every dissertation would have a major and a minor supervisor from the 2 fields, that your desire would be to develop individuals with diverse biographies. If that's the case, it occurs to me, having taught in several countries now, in the US, where doctoral students take a number of courses, in comparison to Europe, where the doctoral students have already taken the courses and now engage in projects, it makes me wonder, is there a core 2 courses that a computer science master's graduate needs to, or could take, which would open up the not the statistics, but the philosophy of social science, the epistemology of social science? Because I think any computer scientist is good enough with math that it would take them 10 minutes to learn a couple of statistics. But why you would use the statistics and the philosophical nature of proofs and arguments, that might take a semester, or at least half a semester. I wonder what your thinking is about that.
We have such a
this special scheme with this strange name, Research Training Group, has especially this in mind, that in addition to your completed masters, you take a course or 2 that enables you to do this specific interdisciplinary kind of research. And we got very good experience with taking such a course and then also organizing a course jointly with master students coming from the two different disciplines, and you have two very young PhD students that organize a seminar on a topic, and you know, in the second year at least they can easily do that, and they learn an awful lot from that.
You know, I was wondering for you, I mean, you have this interdisciplinary background.
Yeah, it's even a little bit more than you mentioned. So I studied electrical engineering, did my PhD in computer science, got habilitation in psychology, and I'm now in computer science, but more on the computational neuroscience.
And where do you get your students from? That's also an interesting question, the input. Where do they come from?
They come from very different fields, also very international. So it's not purely traditional computer science. So I think interdisciplinarity in a single person, that's, I think, a very valuable thing, but I don't think that you can enforce it to the students. If somebody likes to go that path, I think you should establish the settings to support him in that way, but it can't be every person who can do this. So therefore, I think the traditional PhD should be the standard, and then if somebody wants to go further, we should support these people.
So I was not sure why you thought, you said that this is an alternative. I think it will be both. Huh? So all of our students will know more about the other discipline than ordinary students, and this makes it possible that they work in other teams, that they will get jobs or are qualified for jobs that other people aren't qualified for. And well, about the philosophy, I'm not sure if we have a really dedicated lecture about this, because we say, okay, we teach them the methods, but I think this is what the idea here is, that they teach each other, because we have these interdisciplinary working groups, and there they work on very concrete problems, and then they can exchange their views on what all this is good for. So I think it's covered, but perhaps not in this formal way you suggest.
I have one little comment on what you said about you know, PhD duration and effort. I would like to encourage people here in the room, because I have very good experience from our first RTG on interdisciplinary with pedagogy, where I had my shortest PhD times in this RTG. You know, one with 2.5 years and two with under 3 years, and it's rare to find. And why was that the case? Because if you do a PhD, it takes a while until you understand your field, state of the art and everything, and then comes the question, okay, now I kind of understand the field, and now I want to be better than everybody else, which is difficult. You can do it the Japanese way, a little faster, a little smarter, a little something, you know, add some characteristic where you are better than everybody else. And if you look through the eyes of another discipline on the field, you become so creative, and you have such new ideas that you can really leap forward, you know, so it's really worth the effort. And vice versa, when people from other disciplines really understand what this technology can do and cannot do, you know, the right level between over and under expectations, they can also benefit a lot. So I would encourage people to take it not as a burden, but really as a chance.
I think we should take input from the audience, Jürgen.
Yeah. One of the big questions is, why does my paper not get accepted? I think in psychology, one of the reasons is that you don't have sufficient evidence for your theory. In computer science, at least for the more constructive disciplines, it is if you cannot prove the advantage of your system over others. So I was very fascinated by the fallacies that Joe Walter mentioned in his talk, and I believe many of the computer science people have a built-in bias, of course, because they have to show that their system is better, especially in a field like human computer interaction, where we always have to do empirical tests. I'm not sure whether we couldn't throw away 80% of these studies because they wouldn't live up to the requirements. that you mentioned. So my question is really, shouldn't we better split up these joint, say, publication activities? And maybe for the more constructive parts, there's a big discussion whether we actually should have empirical studies with innovative ideas and constructive things, or you better leave them out altogether. So that would be one model that focuses maybe on the innovation, but then identify common questions that are really sort of the core or the intersection of the field, and then study them more in more detail and maybe more theory guided than we currently do. I mean, that would sort of not be along really the disciplines, but splitting up the issues in terms of which discipline contribute the most. So I was wondering whether that might be a feasible model.
Very innovative.
I mean, I have suffered from that in the CSCL community. You do computer science, you bring it to the CSCL community, computer supported collaborative learning, nobody cares. I mean, about computer science. I mean, they care about what you do, I mean, the studies, the learning scenarios, your empirical results, but computer science is not of interest to the majority of the community. And that's something that I think here in this group we should not admit. We should. I mean, I know that I think what you said is a discussion in the human-computer interaction community that you differentiate.
Definitely there, but also in other areas.
Yeah. I must say that in my interdisciplinary communities, I cannot imagine that this would happen. I like it. I like the idea. Yeah. Okay, but so you wanted to say something.
Well, I mean, we are struggling with this issue, and I think it's good to be flexible, just to have different solutions depending on the questions that are arising. That's a very Solomonic answer, but I think it's the truth, because, for example, we have some projects where, in fact, people learn from psychology that certain processes might be helpful to solve a computer science problem, and vice versa. And learning this in this exchange that is structured in these RPGs is certainly a very high benefit, and you can save time when you learn from the research that is already available and not wait before somebody from the other department has done the research and you then can start to build your program, for instance. So this exchange of constructs, for instance, and ideas is very important. It's a real asset of this RPG as well, I believe this. But I think timing is an issue, and I don't want to be the person who spoils the party when you're just starting. But I think it's so important with our experience to think about time from the beginning on, because 3 years are gone like that. And it's good to have a good perspective, what is realistic, also for the PIs of course, because I myself learned in the process what are realistic expectations actually and what are not realistic expectations, just to have a good planning and to have realistic approaches. So more flexibility would be my answer.
Of course, I mean, we have had our talks about the time of the program, and it's always something that it's high pressure on us. So at least what I try to do from my side is to try to build a common solid ground for multiple disciplines in our IWG, in our interdisciplinary working group, based on the premise that no matter what we are going to achieve in this group, it has to be beneficial for each of our individual pieces. So I think that that's the way that at least we are trying to find ourselves comfortable working together. I think that was a good idea of the IWG. It takes a lot of effort, and of course we all have to make some trade-off in trying to achieve this together.
So I have a question on supervision. I hope I don't get in trouble with my supervisors here, but I'm wondering, so in your experience and in your perspective, RTGs, like what would your advice be to us when it comes to reconciling the different input that you get, and the different feedback that you get from your supervisors that come from separate disciplines? So that is a question for my
and then tears you apart.
Exactly.
It tears you apart and you don't know what to do now.
Exactly.
Yeah. this is the case.
Yeah. Well, which is not, I'm not saying that I'm having a hard time, but which is that in the foreseeable future.
Somebody you know had that
Yes,
problem.
exactly. It had nothing to do with our meeting last week. But like inevitably, like it will come to that. The onus falls on the student to be flexible. So,
But let me take your question, and in my answer I would like to convey two things that are specific to our local situation here. First, we have students, the students from here, many of them, I think most of them, come from our Comedia program.
more than half.
Yeah, no, but not all the locals come from the Comedia program, but we have the Comedia program, which is a program that is just a blend of you can say an integration in some way of psychology with computer science, where of course you have your main focus, that's okay, but you learn all the basics of all two disciplines. I mean, you learn the statistics and you learn some programming and formal modeling, etc. So in this sense, we have people coming in who are of that type. I mean, for the others, my point would be, yes, I would like to have method exchange, but you cannot have it on a broad scale. I mean, you need focal points. I mean, there's this notion of boundary concept that maybe we boundary objects, but I always associate that also with specific concepts that we use that are particularly interesting focal points for your exchange. And in my understanding, for instance, network analysis is a very interesting boundary area. We have heard Ulrike's talk, and I think if you want to do such things, it would be good to learn things that you usually do not learn in psychology. Yeah? And that can come from computer science. And of course, these will be specific focal points where you really adopt methodology from the other discipline. That was my local comment.
I'm not sure. Did this answer your question? I understood it completely differently.
Yeah, me
Maybe
too.
you get one comment that says it's great, and from the other supervisor you get the comment, oh, don't know. So, you know, at our kickoff meeting, I told everybody that before I went to university, I made an apprenticeship in a bank.
Okay.
And there, the hierarchy, you know, the one higher in the hierarchy was right. Okay, and I think science is so great because you kind of have a scientific discourse. So I would say you get these different inputs. You think about it. Then you perhaps come to a conclusion, or you want to have a discussion. And then perhaps you can discuss with your supervisors what is now right. Is it this way or the other way? I mean, this is just scientific discourse. I mean, for you it's more difficult because you get the input from two disciplines, but it's on the other hand also quite rewarding and more interesting.
But what happens is, like, after I've met with supervisor A and supervisor B, I'm left kind of alone with my thoughts.
You meet them together.
Yes. And then after that, even then, that kind of leaves you alone to kind of reconcile what you've heard. And like,
you can have them quarrel.
You have to report back and you have to project the problem to your supervisor.
But like,
I would like to give this last part of this panel discussion another turn that is a bit more content oriented. I think these methodological organizational issues are all very interesting for us, particularly also to learn from the RTGs that have more experience. But we also have some content level overlap between at least two of the RTGs and also other people here. And this is this notion of trust and privacy as design challenges. And of course, computer science has something to maybe to support the solution of such problems. And of course, the first issue, we heard that already, is how can we agree on how can we achieve common ground when we talk about trust and privacy issues? And I would particularly ask Max Mühlhäuser and Guido Hertel from Münster to tell us a bit about their take on these problems.
We didn't find it all too difficult. There's more differences in the notion of trust, but they are not incompatible. In computer science, we have a rather small sub-discipline that does research in computational trust, which means you have models of how trust is achieved and how you can calculate trust levels, meaning that you have a certain expectation about the future behavior. When I lend you money, I have the expectation I'll get it back, right? When I tell you a secret, I have the expectation that you won't tell it to others. So this is what creates trust. I have this expectation with a very high likelihood you will not, And if I lend you 10 euros, the likelihood may be lower. I say, okay, there's a residual chance I'll not get back 10 euros, so what? But for 1 million, you want your certainty to be very high, So these models are at the core of what we do in computer science. And of course, social sciences and other disciplines have other models of trust that are, much more related to how trust is built, for instance, in social networks and social media. And of course, we have to now bring these two models together, and that is lots of fun, I would say. As to privacy, things are easier because over the years, the notions of privacy have overlapped much more. I'll give you one example. When we have these things here, and we talk about privacy, then it's all about personally identifiable information. So when there's a piece of data and I can link that to you as a person, then privacy matters, and then all our legislation, Datenschutz and what you have, data protection law, all this applies. Now we found out that if you have sensors on this device or in this environment here, the sensor data look like they have nothing to do with persons, say temperature. And maybe in 5 years, Google has a smart algorithm that can relate, temperature curves over hundreds of sensors and trace you as a person, and suddenly it becomes personally identifiable information. And then the privacy law of today has no answer whatsoever, because it was not PII when it was collected. It suddenly becomes PII 5 years later, and they need a totally different framework of doing their legal issues. So it's not so much an issue of different models in privacy. We have pretty much the same notion of privacy, but it has lots of different facets that are disciplinary. I don't know the English terms. It's Vorsorge, Rechtsrahmen. That's one legal framework in which.
These words are only there in German.
The concepts are
very good, classic. So,
can you take that up?
Yeah. Well, from our experience, we just started to find out that the trust, which is the focal construct in our RPG, is perceived very differently from disciplines. For instance, economics just say, well, there is no trust. There's only trustworthiness. If you have trustworthiness, then all the decisions come. You don't need trust, actually. Psychologists would say, well, trust is an experience, it's a state, it's something you experience, and that's the main thing, actually. So you can feel trust, or you can have cognitive trust, whatever that is. But it's a state. So these discussions were very fruitful in the beginning. We agreed very quickly, thank God, on one model that has these different aspects, which is the Myers-Golan model, which is actually highly accepted in the different communities, but which offered the opportunity to test these different conceptions in the same model. And that is very helpful, actually, if you have an integrative framework where you can integrate the different perspectives from different subject areas. However, after working with this model for the first period, now we are extending this, and we are building actually more complicated forms of this model depending on what you apply this model. So that it's an emerging process, actually, which is quite nice for a focal concept. For other concepts that are not focal, you don't have the time to do that. So you want to have models that are most ubiquitous and also accepted in different communities. However, what also changed is actually the relation between trust and digitalization. In the beginning, we started, well, digitalization makes trust more difficult because there's no direct contact. Over the different projects, we found out, well, digitalization can facilitate building and maintaining trust because it provides transparency. So if you have transparency, sometimes it's easier to have trust, or even you don't need trust anymore. So the relation between the central constructs also has changed over the process of this project, the ITG. And this is actually wonderful because you start with a very basic assumption, and then during the process you develop this to a more complicated but also to a more integrative model.
So, yeah.
I think this is a fascinating example, and it's very, very opportune that it came up, issues of trust, and some of the comments that you've given, and the terms that you've used, and how their meaning has shifted. I think this is a nice example to help you think about how to solve your problem of the division, which isn't necessarily there. When I first heard the name of the effort was user-centered social media, it reminded me immediately of user-centered design, which focused on the individuals and trying to find out what they needed. I think it had a lot of shortcomings as a movement, but it's an interesting idea. I can imagine that you hearing some users say, I wish that my system would show me if a seller is trustworthy, so I could decide, I could feel confident about trusting him to deliver a product. Now, to have trustworthy and trust in the same sentence means they must be two different constructs. And your job then is to find out what it is. So trustworthiness, of course, and this research has been largely done, but to be able to see not that a seller's delivery ratio is 4:1, but the frequency is actually 400 to 100. It's better to have the frequency because research has shown that shows that the person has a history. It's resonant research from a while back. But the challenge for the computational challenge is how do we design a system that shows somebody's trustworthiness, that is their delivery history, and then the measure of whether somebody then trusts somebody is a behavioral or behavioral economic measure. So if you bring that, my sense is, and I don't mean to oversimplify everything, my sense is if you bring the question and the research proposal to your two supervisors, saying I want to work on a project on the computational evidence of trustworthiness to discover it affects people's trusting behavior in purchasing, you're not going to have a conflict. You're talking about a computational construct, a behavioral construct, and people will have a party when you bring that question to them. So I don't anticipate as much conflict as you might if the question is simple and at the same time broad, that it covers constructs from both fields.
Well, this is very interesting because, as you say, this is a wonderful example of the kinds of debates we have to do and to engage in an interdisciplinary setting. Among us, again, in a very interdisciplinary setting, we came to a slightly different notion of these terms. In that we say, trust, as I said, means I trust you. I'm ready to make this risky engagement. I'm ready to lend you $10. I'm ready to share the secret with you. So I trust you means my internal, very subjective assessment of the expectation value of whether or not you will behave as expected is high enough for me to engage. So I have a certain expectation, okay, with 90%, I think the $10 will come back. That's sufficient for me to engage and to lend you the $10. So I trust, okay? Trustworthy is a different question. Are you trustworthy? Are you worth to trust? This is something you can usually only say ex ante. You can say, I got my $10 back, so you were worthy to trust. So trustworthiness in this concept is very difficult to deal with in preparation. In preparation of any activity, in looking at someone, you can assign a trust score, a trust value, which is this expectation value, and from that on you can say is it above threshold, then I trust, is it below threshold, then I mistrust.
This is trustworthiness, right?
Yeah.
This is
So we are pretty close, the terms are a little bit different. And that's the task of the RTG, to come to a common model, so that after a little while, all these terminology discussions are set aside, and we say, this is how we define it, everybody agrees, and now we do our work.
So I think for a final round, yeah, I think in the final round, my suggestion would be that the different panelists would maybe continue elaborating on some of the arguments, but in terms of telling us something about the expected achievements from their RTG. I mean, maybe regarding mechanisms to better handle trust and trustworthiness, or other concepts that you may want to explain. The point is, I mean, when we proposed our RTG, we were also often thinking about how can we make sure that people understand we are needed because of the results that we will bring to the world. So what is the result that you will bring to the world? And you both have been just through the intermediate evaluation, right? Is it the same for you in chemistry, or?
We submitted our proposal and we will
Oh, you have it, yeah.
We will revisit it in January.
So we are always in such situations, and the point is, what will we bring to the world, just by example, from our research training group? Would it be unfair to ask you?
Yeah. The expected outcomes that at least I have. Well, I mean, before starting, I used to work in the industry, and basically what I see very often is that requirement elicitation is very neglected in our profession. So since this has a social nature of the problem, I mean, we cannot afford neglecting that. So at least and that's why I always think that without a psychological perspective, I will not be able to do my software engineering job. So what I'm saying is that using psychologists to elicit requirements of the users in a more, how would I say, realistic way than the inferences that we often do in the while we are developing software. I think that's the first one, and documenting that in using formal models or methods in a very formal description of what this requirements should be. It would be one. And since I'm working in the privacy area, what we started working is on raising awareness on users, because we have the situation that first of all, users do not behave in the same way online than offline. We do not walk in the street sharing pictures with our families to strangers, and we often do that online. So that's why I personally think that raising awareness is very important, and about the sensitiveness of the information that is shared. Of course, we do not know how important and how can this information that we're sharing can be used to disclose ourselves in real life. So I think that from my side, awareness is what I would like to achieve. Yeah.
So better awareness mechanisms.
Yes, exactly. Better awareness mechanisms.
Well, because we just had the explanation, I think that's the reason why I'm so a little bit focused on efficiency and presentation completion time. So again, sorry, I don't want to spoil your enthusiasm, not at all. But that, of course, is one of the criteria actually, and I think it's correct. It's okay. I think
Extrinsic.
It's
I mean,
this is one thing that one of the tasks we have is just to support and help you. To finish wonderful dissertations in time. However, of course, there are many other gains and benefits and goals we have, and that in our RTG RTG goes from insights and scientific learning to building devices for technologies that help to build trust, that help to maintain and repair trust, and that maybe well, makes this world a better place in a way. So it's the whole range actually, from understanding very basic science endeavors to very much applied projects. We have the whole spectrum, and I think it's interesting to have this in the same RTG when you have a clear focus. So the trust focus enables that. If you have a broader thematic focus, I think it's more difficult to have this whole range of research approaches. So in our RTG, I think it's the whole range actually, and I find this interesting.
Our RTG is a little bit more heterogeneous, so we don't have of course we have a heading, but not a particular topic like trust. So therefore, it's not that we really focus on solving a particular question there. And then also I think, of course, we have to agree on different terms in different disciplines, but what I think is that there's some danger in the interdisciplinary setting, that you might get lost, so the PhD student might get lost from the too much interdisciplinary environment. They have many discussions, which is good initially, but then they should get focused and really do excellent research in their field. And I think that is what you should take care. In the end, you have a good PhD candidate with good research qualities, maybe a good publication or two, and not that he got lost in too many interdisciplinary questions they or she was to solve. Yeah, there's some danger in that, I think, and I would like to emphasize this danger.
Okay. Of course, like all of us, we have many goals, so I'll pick just one goal content-wise and one goal with respect to the PhDs. Okay. Content-wise, number one goal is the following. We imagine in the future people having such a device, and this device helping to keep data private to the extent I want, to the extent that is good for me. And this device to help us assess, should I trust this person in the social media network, this social media provider, this service provider, this sensor over there. And for that, this device is totally inappropriate because it's manufactured by Samsung. There are chips inside that may call home to the US or to China, that has operating systems that I cannot control, etc., etc. So I paid for this device, but I have no control over it. So we need a new, very revolutionary approach to how such a device could look, or a controlling device for this device could look. So that's the number one goal, to be creative and invent something really revolutionary in that respect. With respect to PhDs, I hope that our scaffolding will help them become faster, overcome this disillusionment and depression phases, and can generate as PIs enough trust that they don't do what every PhD candidate tends to do, to hide when they are in trouble. They should come when they're in trouble. If we achieve that, then we'll be good.
Should I really end this because should we leave the last word to our guests?
I think it would be nice if you could end this.
Yes,
I mean,
okay.
we are the hosts, okay? But,
Okay. So, yes, you said that the situation in privacy is less severe than the one in trust, and I would again not tend to agree. It does not. It helps us to a certain extent that we know what privacy is about, namely this personally identifiable information. But it does not help us how to deal with this privacy paradox. And I think this will change our society drastically if we cannot make progress as far as privacy is concerned. We will all be gläserne Bürger. And we, yes, we won't get a job if we have some opinions that are not liked. We won't get a health insurance, and even we can be manipulated as to what party we will elect. And so this is even puts democracy in danger. And so I think there is very, very much at stake that we really have to make some progress in this privacy issue. And as Nicolas pointed out, we as computer scientists, we can imagine nice techniques, but why don't they use that? So without the psychologists, we are completely lost. Mm-hmm. And so I think as an outcome, I would like to make progress on this very severe societal situation.
I'm afraid I have to agree this time.
I would say, and we are on schedule. And thanks for your patience, thanks for your attention, thanks for your interaction, and thanks for the excellent talks that we had over the day. I've only heard really appraisal by visitors, and we had a very nice response, as you have seen. This was just to the limit of what we could, number of people, what we could host here. And yeah. So I think this was it for the symposium. Thanks to all. Also to this really challenging public and the support that you demonstrated to us in this early stage of our research training group. And it's always good to learn from others. But we have to make our own mistakes. That's certainly true. So thank you. And thanks to Krista. Sure. Please come. Without him, we wouldn't have had this day in this way. Yeah.